Yeah. All right. So welcome everybody. This is the 6/11/22 meeting of the Robotic Society of Southern California. My name is Ben. I am the current president, and I am here in our new meeting place in Cal State Long Beach. We will be continuing these on in-person meetings for the foreseeable future, unless something else happens with COVID or whatever. But so far, everything's been good. So we will continue the online meetings here, Cal State University Long Beach. Welcome to everybody that's online. I don't see anybody from Riverside. Oh, Danny's there. Hey, Danny. So we have two speakers. One will be Alan. The first lecture will be by Alan, and then after that will be followed by Jim. After the two lectures, we usually have a short lunch break, which will be followed by our business meeting. And right after the business meeting is the show and tell. So if anybody online has a show and tell they would like to present, write it down in the chat. I will be monitoring the chat all this time. And when I see somebody messages that they have a show and tell, I will put you on the list. So far, we only have two show and tells. So with that, Alan.
All right, good morning, everyone. Let me go ahead and share my screen really quick. So in today's talk, I wanted to share with you one or two of the additional components that went into the chatbot that I've demonstrated a couple of times. And I know I've mentioned it a couple of times as well, but really for hardware accelerated deep learning, Nvidia is the only game in town. Now you'll see some papers and some articles about AMD and some of their offerings, but every data center, every research center, anywhere that's doing substantive hardware accelerated deep learning, neural network, machine learning type things, you're going to be seeing Nvidia hardware. For home use, any one of their recent video cards that is suddenly a lot easier to get a hold of will work. And then for the data center and research, they have hardware accelerated inference cards that go north of $10,000 each and up. They have clusters available for several hundred thousand. Like this is it. And one of the many things that's super nice about Nvidia is that they make a lot of their software available to their end users. And the stuff that they have on offer is really cutting edge stuff. This is state of the art, or at most 1/2 step behind the state of the art. If you're the kind of person that assumes that companies keep their commercial investment to themselves, this is really the best of the best. And for me, at least, it gives me a taste of what the future is going to look like, and gives me an opportunity to dabble in some of these things. And in the case of my chatbot, tie the automatic speech recognition or ASR model in with that GPT-3 large language model, and to generate output, and then their speech synthesis module for it to say something interesting. So I kind of want to walk you through a portion of their software ecosystem and the kind of treasure hunt, but rewarding treasure hunt that you can go through if you want to take advantage and play with some of these things on your own box. And then we'll look at some example code of the automatic speech recognition model. We'll kind of, we're not going to drain each line in the code, but show you generally how it works and how to integrate that into your own projects. Now, all the stuff that I'm showing you today, it does have to run on Nvidia hardware. It's Nvidia hardware accelerated stuff. So generally that means for most of us, unless you're a well-funded research lab, an Nvidia graphics card, which has higher power requirements. There's nothing to keep you from designing a robot large enough to have a full-size PC and a 300-watt graphics card in there and the battery, if that's what you're designing around. In my case, I'm still thinking smaller, And I have all of this stuff running on my home computer. So you could call this cloud local. It's running on my home computer, and then I'm connecting to my home network via a VPN to take advantage of all that horsepower from where we're at. The laptop that I'm demoing on today has an integrated Intel GPU, so it wouldn't be able to run it directly. So the first thing we're going to do is we're going to connect back over to my home network through OpenVPN.
Do you recommend OpenVPN, and using VPN is a smart thing to do in any public?
Yeah, it can be. My router supports 3 different VPN clients. I just happen to choose OpenVPN because I like the logo. Yeah, any one of them will.
But you should use a VPN probably, huh? Because I haven't been really, when you're at hotels or whatever, you should.
Yeah, it would if you're concerned about data eavesdropping in a foreign location, then that's the best way of keeping it out of prying eyes for sure. Yeah. All right, so now that we're connected, I'm going to open up my my favorite SSH client, MOBA Extern. Why is it my favorite? Because it's free, open source, and has a dark mode. I have an PuTTY SSH client already set up, so we'll go and connect. There it is. And I'll move over to the Riva directory just to get the party started. And I'm going to start everything up. Unfortunately, I can't embiggen the text on this client. That's the one thing that's not awesome about it.
No, that was wrong.
Thank you.
All right, let's give it a moment to get everything kicked up. Now, I'm going to start with really where this talk ends, which means that I'm going to bring the example automated speech module up and kind of let it run in the background while we walk through all of the pieces. So let's embiggen this a little bit more. You can see it. And when working on Zoom, focus on your screen and not the Zoom screen. Okay, got it. All right, so while I'm talking, I'm going to kind of let this run in the background, not necessarily be the focus or distract, but to show you what the ASR solution looks like when it's working. One of the first things that you're going to notice is that it's kind of got a stream of consciousness. It'll show you its best approximation of the text as it hears it. And then as soon as it sees what I call a pregnant pause, or a significant pause in the conversation, it takes all the text that it thinks that it heard, and it runs it through a grammatical parser, a punctuation parser of sorts. And then as a result, you get something that looks a lot closer to English. And it's very accurate, a lot less sensitive to noise. And overall, I've found this tool to be way, I wouldn't say better necessarily or easier, way more robust than comparable on robot solutions that we've kind of seen in the past. Now, you have to have a lot of hardware and a whole bunch of stuff set up to take advantage of this. But it gives us a taste of what the future holds for onboard or on the edge computing, which is pretty cool. It also has a pretty broad vocabulary. Oh, sorry, Jim. Yeah.
Do you ever have a issue with the audio getting transmitted or delays or what do you call it? Any kind of latency because your voice is being transmitted, right? It's being sampled, transmitted over the internet. You got to have a pretty decent internet connection. And I mean, I've had problems with Google, especially from a mobile platform. It's roaming around. And do you have? I mean, it seems very responsive. So it's very quick in sending the sampling your voice at, I guess, a minimal but appropriate level of sampling, and then sending it, being able to interpret it at the cloud side and and then send a response.
Yeah, so that's a great question. One of the things that you're looking for when you're setting up an end-to-end solution is all the components and their bandwidth. Now, one of the things you're seeing on screen right now is the repetition of a line. That's an artifact of the module that's displaying the intermediate text on screen. It's just a visual thing. It has nothing to do with how it's processing in the background. So in all the times that I've tried this, it's used end-to-end broadband. So Wi-Fi, broadband connections, VPN. I haven't tested it in a situation where I was sending data over cellular, and I don't have the numbers to quantify the quantity of data or the data bandwidth required to support this over, but I would expect additional delays and sluggishness if I went through my cellular provider as opposed to, Wi-Fi fat pipes from here to there.
But Wi-Fi, I was mainly interested in Wi-Fi.
Yeah.
But it's, it seems pretty good. And then, but Wi-Fi, maybe from a roving robot, I've had a little less success than, or it's a little less reliable than a stationary Wi-Fi computer,
Yeah, for sure. And so, in this case, I haven't tried this on a mobile robot yet. I suspect that I'll run into many of the same things that you have. So mobile robots, first and foremost, they make noise, right? You have the audio noise of the motor and noise of crunching on the carpet and all these extra things that I think were difficult. And then beyond that, you have electrical noise, right? So this mic sitting on a laptop with a hopefully pretty well isolated fan, the mic is okay, but it's not great. Now you try this on a mobile platform where you have, two drive motors, driving amps, and no matter how good your filtering is, you've got some noise on the main lines. Yeah, I have not seen a mic successfully deployed on a mobile robot yet. I think yours is the first. But
I mean, I try to use a device that's designed for voice interaction. My even inexpensive Bluetooth speaker mic combo that is designed to handle that, or you could use like the Echo, Alexa Echo, or something. If you could, something like one of those. Oh, and the new one I have, that is the re-speaker, or the microphone array. That one is designed for this application, so it's much better.
Yeah, and one of the things I'm very curious about is its performance and characteristics on a stationary mobile robot, which we've seen, and then how to characterize its behavior when the mobile robot is being mobile as well. I'm wondering if because my impression from it is it says it's for robotics, but it looks like it's a stationary thing. I don't know if you had a chance to characterize the performance on the mobile robot when it's moving.
Or when it's moving and you say stop. I always am testing that because that's a common thing to do, and it's it is better than my previous solution, that little Bluetooth box with a microphone.
Oh, yeah.
So I think it is reasonable, but it's still, even with the noise and because it has that cancellation capability. But that re-speaker 2.0 is a microphone array, definitely improves a lot on that. And I'm still, I'll give you more as time goes on about that.
Yeah, for sure. I'm looking forward to it. So probably the only exception to my chat this morning, because I'm going to try to keep this running in the background, I'll add in a few more pauses to give the ASR a chance to finish its line of thought. Here's where we're going to end up. Let me show you how you can get here, what NVIDIA provides and how to get access to it to be able to play around with these things on your own. So I'm going to move this a little bit down. And let's go on a website tour here. All right, so all roads start at the NVIDIA website. A quick Google keyword search for NVIDIA Riva. It used to have a different name. It used to go by NVIDIA Jarvis, if you've been following their tech for a while. but I imagine due to a potential copyright issue, they were required to change the name.
Oh, sure it is. Yeah, that's,
So now all of their tools have been, all of this set of tools has been branded NVIDIA Riva. So they're from getting to one side to the other, they have a couple of different islands of tools you can take advantage of. Another island of tools is called NVIDIA Nemo. And it has a subset of the tools that you can run locally that is more focused around, well, they're both focused around conversational AI models. I spent some time looking in here first, but what I'm going to show you today is the NVIDIA Riva island of tools. The difference is that this is all published through a Docker container. And so just 3 simple clicks. All you have to do is download and configure the Docker container, and then you can take advantage of all these tools without compiling or writing code. And I can't overstate it enough. These are pro-level tools. These are the same tools that they deploy on data centers and call centers with, you know, tens and thousands of audio streams at once. And it is just coolest thing in the world that we have a chance to be able to play with these at no cost. And again, as they are pro-level tools, they have pro-level options. So when you're getting into it, it may look a little bit daunting. So, you know, getting back to getting something working as quickly as possible, we're going to use the example code as much as possible. If you're a Pythonista and fully understand all the Pythonic, idiomatic Python things that they're doing to make this work, to be honest, for my chatbot, I copied and pasted 80% of the example code into a module and just used that. Because at the end of the day, I don't really want to know how the module works. I just want it to work. So that's kind of the my strategy for sharing these things with you this morning. So some fun stuff. This is a Docker container that has an ASR module for automatic speech recognition, a punctuation model to take that speech and to turn it into something that represents printed English, and a speech synthesis module that can take text as an input and output audio. We'll see if I have time to get to the speech synthesis portion yet. I wasn't sure if I would go long and short for today's talk. So we'll see. Recently, they, in one of their talks last month, they updated the toolkit to 2.0. They added in some additional features, one of which Jim was going to I think is going to make you pretty happy. But most importantly to me, they added in a male voice. So I went through, and for me, a large amount of effort to train a voice, and possibly in a future shot, if there's interest, I'll share with you how that portion works. Because I just wanted my system to have a dude's voice. Now there's one that's built into the system. So not only can I leverage that, I haven't even tried to use it yet. I just downloaded the updated one last night. But taking an existing voice as a base, you can customize it. So I may be able to get the default male voice to have a Scottish accent with a lot less training than it took to get my barely passable Scottish voice on my chatbot. All right, so there's a couple of pieces of technology that I'm going to share with you on this treasure hunt to get from the NVIDIA Riva webpage down to running the Docker container that you can use in running the example code. One of the first things that you're going to want to do, though, is you're going to want to sign up for an NVIDIA developer account. None of these tools are behind a paywall, but they are behind a developer sign-in. And there's, you know, as soon as you sign up for it, you're going to get access to it, no problem at all. And so once you sign up as an NVIDIA developer and get your login, here, move some of these things out of the way on the screen if you're following on the screen. There we go. The tool that you're going to use to download the Docker stuff is called NGC, NVIDIA Global Catalog, I think is what it's called. And in order to get that, I just have a screen up here. There's a helpful guide, activating a UCC account. When you register your NGC account, it gives you a key that you're going to save off to one side. There's a lot of, it is security, but it's all available to you at no charge to be able to set this up. So what I do is, as I'm going through, remember what screen I was on for that. You run the NGC tool. You're going to download the NGC tool and then run it. Sorry, I'm skipping around to remember where I wanted to be on this. Scroll, 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 scroll. All right. So it's defaulted to the Windows install. What's nice about this is if you're clinging on to Windows, you're taking away Windows from my cold dead hands. All of this stuff will work under Windows. Now, I wasn't sure what order to do this in, but is everyone familiar with Docker? Is that a thing that? Okay, and for those of you that aren't, if you're familiar with a virtual machine, right, kind of running a pretend machine on a real machine. A Docker is a container. It's a very lightweight, more of a sandbox that allows you to run code completely separate from the host OS. So you don't have the overhead of a full virtual machine and virtualized devices and all that stuff. But it is 100% sandbox. It allows you to do some pretty interesting things. One of these things is that you can, in a Docker container, run a complete version distribution of Linux. And that Docker container can be run whether you're on a Windows host machine or a Linux host machine. Now, I haven't done this under Windows, so I can't say for 100% I know for a fact that there's no hangups.
Oh, yeah, there is Docker for desktop. I just downloaded recently. Of course, I haven't tried your case, but for Windows, Docker desktop for Windows, it seems to be getting good reviews and good, and it is, designed for Windows. And it uses, I think the one key thing though is it uses the WSL infrastructure inside Windows and the hypervisor. So that one, I think you don't even need the professional. I'm not 100% sure, but yeah, I've started to look into that.
Okay.
Although, yeah, for something like this, I don't know if I stick with Windows or not, and in this case, but
yeah. So and so one of the cool things about it, which actually helps us, so we don't have to recompile all this stuff from scratch, is that NVIDIA is supplying a Docker container that is pre-configured to run all of these NVIDIA Riva services. All you have to do is download and click basically one command, and it downloads and configures everything for you. And so as long as you have an NVIDIA graphics card on your host PC, whether Windows or Linux, you can follow these steps and end up with a fully functioning Riva solution that is itself Linux, even if you're on a Windows box.
yeah, well, in fact, the Windows one, if you do have that WSL, it uses that engine, the Docker for desktop, which is nice because it's something you may already have on your Windows. It's like, I've been promoting, I guess, in some ways, that WSL too.
Oh, nice. Okay. All right. So the way that because this is running on my box at home, I follow the Linux version. It's a matter of copying and pasting a couple of statements, and then to get the NGC application. And then you When you download the appropriate Riva Quick Start, it downloads about a dozen files. They're all scripts. It's very lightweight, takes like a second to download. Once that's downloaded, you'll go into that directory. In this case, the most recent one is Riva Quick Start 2.2. And the first command that you're going to run is bash riva init. And this is the command where all the magic happens. It downloads the Linux Docker base container. It downloads all of the supporting files. It downloads all the install scripts for the deep learning stuff based on the graphics card that you have available. It compiles, pre-compiles everything so that it runs as efficiently as possible on your hardware. And this process can take up to an hour. On my box at home, it takes about 20 minutes to fully download and configure everything. And this is where I ran into my first problem last night, because I'd done all this months ago, right? So I'm like, you know what, let's start walking through this. So last night, because you know, I have enough time, I go back to my computer and I try to launch the Docker container, and nothing happens. After a moment of panic, realizing that every problem has its own solution, and most of my problems are self-created, I discovered something, or rediscovered something about Docker, or Nvidia Docker containers in this type of a project. Now, if you remember from a minute earlier, I said that when you download the Docker container, it compiles, configures the machine learning code based on the graphics card you have on your machine. I always run, I always download the most updated version of everything on my host machine, including the graphics card driver. I just do. I'm a glutton for punishment. So in one of those driver updates, it invalidated the pre-compiled code for the Docker container. So I had to do a clean to get rid of it. And then once I let it spend, because now this is how I know it's 20 minutes, let it re-download and compile everything, it worked fine. But yeah, a few moments of panic, right? Because I do live demos, I don't pre-record anything. And I was wondering what my plan B would be if I just had to wave my hands for an hour. Okay, here's what it would look like if it worked. You know, just type it on the screen. So yeah, obviously it's working right now. And I know we hear over and over again, like, oh, when, I updated Linux and everything broke. Well, the same thing can happen on Windows. And in this case, I just take a deep breath, retrace my steps, and after reinstalling it, everything was fine.
No, this was on Windows, or
This was under Linux.
This is under Linux.
Yeah.
So the takeaway here is if you do decide to upgrade your video card drivers, then keep in mind it won't tell. Well, did you get a decent error message that told you, or
Unfortunately, no, it just didn't launch.
Okay, so that's valuable knowledge then.
Yeah.
So the procedure is if you do upgrade, then you need to wipe clean. There's some essential clean command, and then you build it again.
Yeah, and in this case, it's just two simple commands. The whole process takes less than 20 minutes. But this was on the IT side, we always joke about turning it off and turning it on again. Okay, let's uninstall the Docker container and then reinstall and see if it still works. So after about 20 minutes after Riva init, everything downloads, configures, and installs. Let's embiggen this a little bit. And to kick everything off, to kick off the Docker container with all of these tools available, it's one simple command. It's a script called rivastart. Now, let me show you a little bit about what happens behind the scenes before you click on that. I have a local copy of that entire directory over here. And the file that I want to draw your attention to is the file that configures the Docker when you run it. So when you run riv_start, this is the configuration file that it looks at to know what you want it to do. And there are a couple of options here. We have three flags of the things you may want to touch. The first three things that you may want to touch are which services you want to enable. ASR and NLP are consider them paired services. One is for the speech recognition and one is for the punctuation. Having them set to true means that it's going to load in the appropriate modules when you launch the Docker container, and set to false means it's going to skip them. The third one, TTS, for text to speech. That's going to be your speech synthesizer if this is set to true. It will load up the appropriate modules, and set defaults, it'll skip that part. So if you're on maybe a memory constrained system, or it's just you don't want to take advantage of that one feature or the other, just set them defaults, and when you launch the Docker container, it'll skip those steps. The default English US as opposed to English UK or American. The system defaults to GPU 0. If you are in a situation where you have multiple GPUs, you can set this to whatever your 0 index GPU number is. If you have like a fat GPU and a skinny GPU, and your fat GPU is GPU 1 that you want to use for all your inference, you can set that to a 1. The rest of these things I probably wouldn't touch. If for some reason you need these services to run on a different port, you can change that port. I see no need to do it otherwise. The rest of it got a little bit more complicated once they started supporting ARM64 stuff. So there's some switches to pull in a different module based on whether you're running on a Windows PC or on one of their devices like Orin. I think that's why they did it. And they have a couple of different models now. One of the cool things that doesn't really affect you, but is there, is they now support multiple languages. So German, Spanish, Hindi, very interesting. They have a couple of different ASR modules you can take advantage of. I just leave it at the default. And then scrolling down, there's just lots of stuff.
So you can, yeah, you can leave most of that alone.
Yeah.
It sounds like, at least to start with.
Exactly.
Very cool.
The other cool thing that I see down here is that they do support male and a female voice now. The female is enabled by default. So if we want to enable the male, we could comment out one line and uncomment the other to support that. And that's really all the things that I want to touch in there is, you know, mostly towards the top. If you're only doing ASR stuff, you could set the TPS module to true and save you a couple of cycles on the card. So we'll hit save and exit out. And going back to,
You mean false, right? You said
oh,
save.
to false, yeah, correct.
Save.
If you wanted to skip that portion of it. And then once you run in Nvidia start, or sorry, Riva start, all these things run in the background. Okay, so everything's running. Great. The next step is how do you take advantage of them? It's a Docker container running microservices in a little sandbox on your computer somewhere. How do you get at them? So in the 20 files that, here, let me embed this a little bit. Oh, sorry, this way. There we go. They have some example Python files. Notice all the examples are in Python. Python is the future, in case anyone asks. Python is the future. Now, one of the first files I just want to show you really quick is the transcribe file, because it's probably one of the simpler ones. Lots of boilerplate comments about no implied purpose, don't sue us if something gets damaged. The way that your Python code, the way you communicate with the Docker container is through a lightweight, almost like an RPC. It's a remote procedure protocol called grpcio. It's a Google lightweight protocol for exchanging messages and functions over the internet. And so your first clue that you have to get something else installed, aside from the source file, is that if you try to run this file, you know, python.py, you get this error message about grpc.py. The technology that it uses to pass messages back and forth is grpc. And in order to install that, all you have to do is do a pip3 install, and I always get the letters in the wrong order, grpcio. And it'll install the required library, and now you can speak grpc. The second thing that you're going to have to install, just going through this, is that there's a series of Java classes that you need in order to pass messages back and forth through gRPC. They conveniently provide that file for you. Right here. It's a wheel file, so it is much like doing a pip or a pip3 install from the online library. You can use wheel to install a local library. And if you're anything like me, as soon as I get the example code, I try to run it, and then I work through the error messages to figure out why it won't run. These are the two reasons why any of these examples won't run. Is you'll want to install that Google RPC IO package, grpcio, and
then those wheels come with the software, or?
Yeah. So when you download that that Nvidia Riva install, it comes with all the example files as well as the wheel file in the same directory.
Did they tell you? Did they have instructions? Please install
I'm
it?
sure they're there somewhere.
Oh, okay.
Yeah.
Probably. That's one thing I try to do is follow, if there's instructions, follow them first before getting too excited to run them.
So you do a wheel install Riva, and then it installs the rest of these support files. So, so those are the two background things. And so since I'm running these scripts locally on my laptop, I have to do this locally on my laptop in order to connect to the server, which is not on the same computer.
Oh. Oh, so you can separate you need those to be able to do any of this, and then but you're separate somehow. Oh, the remote procedure call that's the mechanism that it's going across to the cloud, right?
Yeah, exactly. And even if you're running the Docker container on the same box that you're running the scripts, it's still gRPC. And it's still the same protocol. And so this is kind of the word salad treasure hunt to get from A to point B, is to take advantage of the out of the box stuff. You'll be using Docker, and then you'll follow the NVIDIA developer directions to create an account, and then to download the Docker, the rivaquickstart, which has the script to download and configure the Docker container, and then run it. And then once you run it, you have to download the gRPC, install the gRPC IO package to be able to communicate back with it. And then there's a wheel file that gives you the missing sorry, I said Java, didn't I?
You said
the missing Python classes.
Sorry. It used to be Java.
To be able to communicate. Okay, so that's the treasure hunt, right? And then once you get through, jump through all the hoops, you can take advantage of any of these example files to get a feel for how the system works. Somewhere over here, where we have our sample here, this is almost the out of the box transcribed by Python file that's available in the example. It's still running in the background. It is able to punctuate several sentences at the same time. For instance, this one. Okay, that didn't work out quite right.
I got that. Oh, there's that hum. That hum is dangerous. Careful there. We might.
It's going to threaten you.
Yeah, it may be violence threatened. Inside joke.
All right, so let's explore the ASR module a little bit more in detail by showing you some of the things that it does well, as some of the opportunities for improvement. You'll notice that as it goes through and does a best guess interpretation of the speech that it hears, it'll go back and edit previous words. It's pretty smart and robust in at that point. And then once it hears what I call a pregnant pause, it'll go back and apply the punctuation module to it and make it into usually a pretty good sentence. And for the most part, it does great. From within the context of a single sentence, it'll do its best to construct a grammatically correct sentence. And if it misinterprets a prior word while it's listening, it'll go back and update that word live as it attempts to make a best guess as to as what the speech is. So far, this is amazing. There's another layer to this that attempts to convert between numbers and letters and capitals and stuff. So if I say 224, it converts that into the numeric representation. Now, what if there's one more thing I have to say? It sees the difference between the number 1 and the ONE. And so it gets, and that works out really well. The punctuation engine uses a robust set of English rules to interpret the input from the ASR module. However, there are some things that it doesn't do super well. And Jim, you've actually already run into this on the onboard module. So let's say I want an attention word. Now, my chatbot, his name is Braden. And depending on the context, it understands that word okay, but it still spells it wrong. It's not my preferred spelling. But if I use a single word as an attention word, sometimes it gets it and sometimes it doesn't. I'll show you that right now. Braden. 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 So sometimes it gets it and sometimes it doesn't, right? So, and it feels a little bit like the GPTJ discussion from last month, but there's sometimes you want the system to take advantage of a context, whether you have an attention word that it needs to get above all else, you have a special spelling of the name, which this guy does, or anything else that you want to use to help us contextualize. In the Riva 1.0 solution, there really wasn't a way to do that. And to take it one step further, the speech synthesis modules that are built into Riva, I've actually taken those modules out and I run them locally. So when I run the Braden chatbot, I'm running the actual code and the scripts off to the side. I haven't figured out how to extract the appropriate modules from the ASR module to take ownership of them. So in the chatbot in here, we're running them out of the container and it works just fine.
Oh, you mean when you say you've taken out the things you did take out, they're out of the Docker into your own native.
Yeah, it's I was able to figure that out. I'm still running the ASR modules inside the container. I just haven't figured out how everything fits together yet.
Oh, is there an advantage? I see. There's an advantage to having to be able to take the things out of the Docker. I assume that you want to, run it natively in your own.
Yeah, it gives you more control over it. Plus that, like in the speech synthesis module, I now understand how the modules work together. So just to get things done, there's no reason to take it out of the Docker container. But because I'm hoping to understand more about how these modules fit together. I'm hoping to be able to understand that and then be able to run them outside of.
Then you could do piecemeal. You could configure things more in a more advanced way, taking modules out and.
Yeah.
Well,
exactly.
do they give? Is there like a instructions on how to install all this from scratch into your own Docker or into your own system, or do they just kind of give you the Docker and say don't bother trying?
Not directly, but you'll find a lot of the scripts in the Nemo ecosystem. There's a lot of overlap. The Riva stuff is prepackaged in Docker. The Nemo is more raw code, and so that's how I was able to piece together these speech synthesis module that's used in the Docker container. I want to draw your attention to something though. This is something that just came out, became available as an option under Riva 2.0. I'm going to open up the grpcio prototype for the ASR modules and functions. And so I was just browsing through this last night, as one does. And there was a very interesting section I want to draw your attention to. There is a new message type called speech context. And speech context allows you to provide a list of words or phrases you would like the ASR module to prefer. So for instance, if I want my bot's attention word to be his name, I want the name to be spelled correctly, well, correctly, B-R-A-Y-D-E-N. I can supply a speech context as part of setting this up. And between the list of words or phrases you'd like it to prefer and they call it a hint boost or a hint boost value, how much you would like to elevate this above the default. And this is, so I haven't been able to make this work yet. This is very new and I haven't found the corresponding documentation to take advantage of it. You can give the ASR module some hints about the type of, I guess it would be input, how you want your input to be understood. So in theory, I can tell it that whenever you hear anything that sounds like Braden, that this is going to be a B-R-A-Y-D-E-N.
I was going to ask that. So would you have some list of B-R-A-I-D-E-N equals B-R-A-Y-D-E-N, or how would you have a bunch of sound-alike words and then equals?
The way I understand it now, again, I haven't made this work yet. The way I understand it from how things are documented in the file is that the problem is homonyms, right? Things that sound alike, and with enough context, the ASR module can sort it out. But if you're doing a one-word utterance, you know, to be able to get it right. So my understanding is one of the input words would be Braden, B-R-A-Y-D-E-N. And so in any combination of homophones or phonemes, visemes that approximates that.
That it thinks sounds like it thinks B-R-A-Y-D-E-N sounds.
Yeah, if it's trying to figure out between 3 or 4 alternatives, it'll bump up your custom list towards the top of that so that if it hears anything that approximates Braden, it'll assume that it's Braden. And so you can use this for attention words, for its name, as well as like if you were doing, if you were setting this up as part of a medical solution for medicine. So you could give it a whole list of things that, hey, if you're choosing between this or something else, this is going to be it, to help tune its ability to process the input to more what you want. And I'm really excited to figure out how this works. For the very least, I want my chatbot to respond to its name and know that it's name. And even when it gets it right, I want it to spell it right. Because in best case, as you saw, it spells Braden.
Well, you bring up a point, like if it was a special use machine and you wanted it, let's say you wanted to say dial 911, let's say it was an emergency machine. You would place preference on what that sentence was, as opposed to some other possible interpretation.
And to take that a step further, so let's say you're setting up a machine learning module as an auto dialer, right? So you may want to restrict, it wouldn't be a restriction so much as in your help docs, you say in order to use the auto dialer, you'll say the word dial and then say the numbers. Your message prompt would include the word dial 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and with a high boost value, so that more often than not, again, so no guarantees, it's non-deterministic, is that it'll be able to interpret your text input based on your allowed intent, which is the word dial and the numbers. So I'm very excited to try this out to see where it goes.
This is very similar. You might remember my talk a couple months ago, where I or show and tell, where I was doing something very similar with the onboard recognition and by training, rebuilding the model, the language model, with a text file of the robot commands and boost. It's the same concept, boosting, except I had to do it offline. But that, I mean, there's still issues. Well, I'd like to test yours. Like if you say something like go forward 4 meters.
Go forward 4 meters.
Okay, and then okay, that worked.
Right, and there you see the contextual in this context attempt. In the input, it read 4 as FOR, but as soon as it parsed it, it did 4. And it has a rule to shorten the word meters to M.
That's pretty good. That's pretty
Try,
good.
try one more. I'll take 4 beers for the road.
I'll take 4 beers for the road.
Yeah, see, the context helps, doesn't it? Or how about I was playing golf for.
I was just playing golf for.
That one's hard. That one's really hard. That's the hardest one.
Just do 4, just like, yeah. Oh,
If you just say for alone, it doesn't have any context, so.
4. 4 score. And 7 years ago.
So, but this system though is better than maybe the one I have because it does use context a bit more maybe than it can figure out. It seems like it can figure out which 4 you mean better than at least the one I have out of the box.
Yeah, it's just a matter of, you know, to compare the two is a little bit disingenuous because the one that you're using can absolutely run on the edge on lower end hardware and does an amazing job, you know, for what it does. Anything you can solve anything when you throw enough hardware at it. So, you know, this is like the like, you know, if you have a full graphics card with hardware acceleration and deep learning models to reinforce it, what it might look like. But you wouldn't necessarily, you know, you couldn't run this unless it was a very big robot with a big battery. Locally, you would have to run on cloud. So with any solution, there's going to be a trade-off. But for me personally, this gives me a taste of what the future's going to look like at the edge, right? So in the next couple of years,
Yeah.
or even maybe on one of those Orin boxes, you know, the little next generation Nvidia ones, if I was ever able to afford one, how well, you know, this might work, work on that. So yeah, so this is the ASR module. You know, once you sign up for an Nvidia developer account, the treasure hunt keyword search is Docker, and then you use their NGC tool to download the quick start. And then when you follow the directions exactly, it takes about 20 minutes to complete the init, where it downloads all the Docker files and configures your Docker container. And then rivastart starts all these microservices back wherever you're running it. You will need to install the grpcio package, so pip3 install grpcio. If you're looking in, based on the error message, and if you're looking in the source code file, the class is grpc. If you keyword search grpc on Google, it'll take you through their project webpage and exactly how to install it. But the name of the module when you're installing it is grpcio. And then once that's installed, you'll have access to that. And then from there, leverage as much of the example code as you can. And in my chatbot, I started out by creating an ASR module, copying and pasting all this code into it. And then instead of it having this, this listen print loop where it prints it on the screen, I then have it put the message to a variable that's then called by another function in the main program. So I can't say I understand any of this code. It's not only very Python-y, but I do know enough to be able to copy and paste it and get it set up for other needs.
Then you integrate it into your other.
Yeah, so I have a module for this and I have a module for ASR, and they pass messages back and forth between that and the main chat program. So the actual chat program is pretty small. All the heavy lifting comes from these support modules off to one side.
Yeah, that's important. It's important that it's not too difficult to integrate into your own needs, at least at the high level. That's critical.
Yeah, so I'm looking forward to taking advantage of that message context type to see if I can get it to at least know its own name. On the speech synthesis side, I'm going to play around with their out-of-the-box male voice, and I'm going to see if I can get that voice, because you can fine-tune voices for different accents and things. I'm gonna see if I can use their well-trained voice. You know, they spent like 10,000 hours on a DGS supercluster, you know, whatever. If I can fine tune it using my Scottish input to get something better than what I currently have. Because what I currently have is passable, but it's not great. And I don't know if I can train it to be great or if I can just fine tune one of theirs. So I was trying to think about what you'd like to hear about for next month. I am going to be working on my end move again. I'm doing a couple of things, maybe in support of the film shoot. Let's see if that falls through again. Would there be interest in like a Docker deep dive, like to understand more about what Docker is and how it works? I think that potentially has a very important place on the list of tools that we can use. Just like Anaconda. So hopefully all of you or most of you are using Anaconda right now to be able to sandbox your different implementations of Python to keep them separate. The Python version of DLL hell, you know, pardon my language, of having incompatible versions of Python modules. You can use Anaconda to keep them separate for the most part. I see Docker as a more extreme version of that, where Anaconda allows you to sandbox your Python details. Docker allows you to have an entire Linux distribution with the exact version of Linux and the exact version of the tools, completely separate. It actually ends up all being in a file. And there's, once you get used to how Docker works, it's a pretty powerful tool. If you're interested, I can talk about that next time.
We can schedule you.
Okay, sounds like a plan.
All right.
So that's all I've got. Thanks, guys.
Thank you, Alan. Good stuff. Jim?
Yeah,
You're up next.
you want to take a couple-minute break?
Okay,
Good
sure.
idea.
So we're gonna take a few minute break, and then continue our second lecture.
So Alan, you went from speech to text in that demo, but then obviously with your voice synthesis, you want to go from text to speech.
Correct. Yep.
And so we haven't seen a demo of that exactly yet. In
It
this,
has
that's something else too. I mean, you're gonna build a file.
no internet.
And then read it out.
Yeah. So the chatbot that I demoed has it, but yeah, we didn't. Okay, so
No, we only have so much time.
Yeah, I wasn't sure if I was gonna go short or long, so I was prepared to like plan a little bit. But yeah, that's those are the two main ones, right? Text to speech and speech to text.
That's what I thought, but it didn't.
This time I this
Yeah,
week
I actually
Wednesday I fly
Oh, okay.
from China to here. I bring some China style fan
Wow, that was very nice.
for you. In traditional, this is 900 handmade, but I think this is machine made.
Oh, that's very nice.
Okay, thank you.
Well, thank you. Thank you. Very nice of you. Thank you very much. It's from China. Wow.
Very Chinese style.
Oh, beautiful.
It's a custom that you visit someone you hate.
Oh, that's very nice of you. Thank you very much. Wow. Wow. So you actually live in China then? Or
Yes, GoPay actually has participated in the past by bringing students
oh, that's very cool.
from China to do what we call multinational games here in the US.
So he lives there right now. Thank you.
Yeah, so he's visiting for several months.
Hey,
right
Ben.
now. Thank you.
Ben,
Yeah.
Okay.
His English is decent,
we taking a break?
but he uses Translate a lot.
Oh, that's really cool.
And during the pandemic, he created some solutions that he wanted to share here in the US. So I invited him.
Oh, I'm so impressed.
Yeah. Also, I got several finches from their CMU product. And they sent me 10 demo finches to use during the summer, and then I have to send them back. So nothing is really free. It's apparently free, but now it means that I've committed to finding 50 people with whom I will share this. So, I can visit Riverside Robotics if you'd like. And if anyone wants to pick one up and look at it, then I'm happy to do that, and then I'll be making some videos about it. So,
Okay,
yeah.
what's the finish?
Oh, a Finch. It's a robotic learning platform created by CMU.
Oh, okay.
And so I will tell you that I got these. At first I thought they were Lego products, and I didn't actually get to them right away. And then I opened the box, and then I finally charged things last night. And so today I can start learning about them.
You're signed up for the show, tell, right?
Yeah.
Perfect, okay.
But I'm not really gonna show much because I just opened the box and just charged them. So,
You want me to put them on the list for showing some?
yes, please, but I have two things I want to show and tell.
Oh, traditional.
One is,
Oh, this is the.
one is called multinational experiences. It's actually more of the tell than show.
Thank you.
And then the
Oh, wow,
other
this turned out.
is called
Better than I
the
expected. Is that a
robot
point
virus
proposal?
video
Yeah,
that I would like to do.
yes. Luggage tag.
Which is why I want to get in here so I can put myself
Do
on.
you know
camera.
Precision?
I made them before, like, the aquarium.
Oh, we're in.
I like the slide, it's good.
Oh, yeah. I didn't do that, that's
Doesn't ring
fine.
a bell. No. I'm sorry.
Oh, no, we're not.
Mhm.
What did I get through to?
Okay.
Okay.
All right, should we get going?
Okay,
Start
go
up.
for it, Jim.
As soon as you're ready, you're up.
So
You're
now
ready.
we're reading a book
Let me
from
check
Chinese
the
writer. Oops. Oh.
All right, hi, everybody. So, today I wanted to kind of shift gears from the normal software, the software stuff that I do as a software engineer. Most of my presentations are kind of revolve around software. In this case, I'm gonna share some of the making type activities I've been doing. It'll be including both a circuit board creation using KiCad, as well as some 3D printed objects with Fusion 360 that I've done over the past several months. So just go through some of the things I'm learning, because I am brand new to KiCad, and which is a really good free software to create your own schematics, as well as circuit board design, and other editor or other capabilities as well, and then generate Gerber files, and that you can send to a company such as this one I have here, JLC PCB, and then your board will get created. And I can show you what it looks like here. Let me switch the camera to Logitech. You should see, can you see the my PC board here? I'll show more of that. Let me see if my is not more nutritious. My camera is being shown anywhere. Can you guys see the my camera feed online, guys? Can you see my camera feed?
Oh, here. So right now you're sharing your screen.
But doesn't it show me, and it should show my camera feed as well, right?
Oh, your little, yes, I see it. It's a small little,
So
Oh, maybe you can pin it.
Yeah, you have to pin his cam. There it is.
Oh, okay, you have to pin it. Yeah, otherwise it doesn't show. Yeah, okay, so there.
No, it still shows his screen.
The screen, it should be both screen and my video, right? 'Cause you
So is that a
can-
board you designed there, Jim?
Yeah, so this board, and I'll go into more details. Yeah, because what I can do is, I switch
Yeah,
between,
he's scroll over to the left, he's down the first.
I can switch between my different cameras here, like this is if you want to see for me, there's me. So, and my screen, I'm sharing the screen too. So I'll go through that. First, I'll talk about the PC board generation and all that. And it's a very useful, extremely useful thing to know if you want to design some small board for your robot. And so what I'll show you first is the schematic editor. The software, if you look, well, this is the main page here. The entry page shows you the different things you can do. You can edit the schematic. You can edit the symbols that are used in the schematic. Then there's the PCB editor. The footprint editor is the actual, what each device, each component actually looks like on the board and in 3D, in fact. Gerber Viewer can load Gerber files, which is your STLs for 3D printing. The Gerber files are all the instructions necessary for a production facility to build your board, or for if you have a laser cutter or if you have your own homebrew board system, you could use those files. And then there's other tools as well. So the schematic editor is where you start. And so here, well, what I started out with was that this is not a robot related board I'm doing, but I wanted to give it to you anyway because, or show you all this because you could easily be making some sort of robotics thing. This is a board for a vintage computer, Commodore PET for an 8-bit audio DAC, a buffered 8-bit audio digital to analog converter for and it's a fairly simple design, and I got this design from an old publication, and I didn't do it myself, but so this was sort of an exercise in taking an existing schematic and turning it into a real, turning it into a modern board. Here's what the original one looked like on paper. And everything is there for you. And I thought, hey, let's try to turn this into a modern board. And well, in fact, there was an old board too. If you look at the, I'll get rid of this. This screenshot of YouTube. I'm sorry about the ad. So this is kind of what the board looks like that I'm trying to essentially reproduce in a modern version of this. And so I already had kind of an idea how to, what I wanted to do. So with that, I started out making the schematic. And now this thing, so you could place components in here and you hook up the wires. And it's a fairly well-designed piece of software with good UI. And there's a full tutorial you can go through that takes you through all the steps, like for a beginner. And now I had to create a new symbol, this one, or two new symbols to handle these connectors, which are old connectors that don't exist in their library. The schematic software has a library of 1,000 or maybe multiple thousands of different components, and different ICs, integrated circuits, and you can look them up by number, like this 405, which is that non-inverting buffer. So that is, just an IC you can buy. But for this, for a custom connector, which is those connectors at the end of the board, I needed to create my own, symbol here. Oh, actually, this symbol existed, this exact what you're seeing here, but I had to customize it, and I had to change I had to make a footprint for it. And so if you do have something like that, that's this part here, these connectors here. There's nobody had, this is not in the library, so I had to make this. That you buy this blue thing, the blue plastic the actual connector you buy, but on the board you need to set up the paths, right? And so you'll have something like this representing in the schematic, representing the user port connector, and then what you do is you edit you create a footprint, and you can save it to your own library. So you can start your own library, and so I started a library to store my modification, my new under Jim there, under my new designs that I needed. And so here you'll have this is the new footprint. The footprint is what is going to be on the actual board. And so there's tools here to create paths and space them out and number them, and even switch layers. Like this is a double-sided thing, so you're going to need, you have to have both sides. And if you can even have a 3D view, which is it's very useful. I'm not sure where the 3D view is. 3D viewer. I'll show that in a minute, but so here, and then there is this one. I had to import this particular audio jack, and so you can find if the component you have is not available in the library, you might be able to find it. Actually, I think it was in this library, but it didn't have a 3D view, so I brought in the 3D view. And there's the 3D view coming up over here. So you can see on the left there's the 3D view of that. And I had to, so this I imported, and then I was able to adjust its offset so that you have that, and then make sure it fits, because this is all theoretical, and when you make these holes in the board, you don't want them to be wrong. So having the 3D model is nice to verify that it's going to actually work when you're finished with that. And so what's going on here? Oh, okay, so if I go back to like this port and try that 3D viewer again here now, for some reason it's doesn't want to, so you can see what it looks like in a 3D preview. So this part is the first part of the process is that you create your schematic, and then you run some tests on it. There's like there's a tool here to go through and look for any sort of obvious mistakes. And then there's a tool to assign the footprints before you can actually go into creating your PC board design. you want to, you're gonna need to assign footprints. So the footprints are, some of them can be automatically assigned, but other ones are not. In fact, I think most of them you have to choose something. So here you'll see, I'm sorry, I don't know if I can zoom in on this text, but for each component, there's a footprint, and you assign those capacitors and resistors, and this can be time consuming, and it's not obvious which one is the right one, so that takes some time. But you need to figure out, you know, how big is the resistor, how big is this component, what's the dimensions of it, and then pick the right one from the menu, because there'll be quite a few listed. Any questions? This, you know, using that, there's a bunch of tools here to place and connect wires and do all that, and then it will, it names everything for you, like resistor number 3, it'll go through and annotate when you click a button. And like I said, it will check for, you can run the checker tool, perform electrical rules check, and that will run a check, and if anything's disconnected or unconnected, or is something that looks wrong, like you've shorted power to ground, it'll find that. And then if you're not using connections, you put these little no connect symbols, and then it won't give you an error for that. So there's a way to avoid errors that that don't help you, because it's what you wanted in the first place. So if not, we'll move on to the next major stage is the PCB layout. And this is really, I think this is fun, honestly. It's you first place the components down, and then you start wiring them. And it's like click, drag, and you automatically will get these nice 45-degree angles, which are mostly recommended. And then you do a fill to the ground plane, for instance, is all this blue area. At the end, when you fill it, you do a fill so that you get a full ground plane, which reduces impedance, I guess, and you want to have that as a sort of a part of your board design. And yeah, so there's 2 steps here. Like I said, you place down these components, get them where you want. Then you'll have something called the rat's nest, which is all the connections will just be straight lines instead of these nice final traces that I've made. They'll just be these white lines, and it makes this rat's nest. And so then you go through and you design each one, you route each of these to where it's supposed to go, and it will tells you where it's supposed to go. Automatically, it will show you, like if you click here, I think it's E or something. There's a lot of hotkeys too, but it's not, is it E? No, I guess it's not E. Forget what it is. X. Oh, it's X. So when you type X, or you use it shows you where electrically you're supposed to have this signal going. And so before the rat's nest is gone, you'll have, you see that little thin line there, that's kind of what the rat's nest is made out of, these little tiny, very thin lines that tell you essentially where you need to go. And the highlighted pads are the ones that where this electrical connection is going to go. So that makes it pretty easy for you to know where you need to connect things.
So even though you had a schematic, you still have to draw out the connections?
Yeah, so the schematic is like a starting point. And then when you first, I'm not, to save time, I'm not going to go through every like from scratch. I guess at another time I could go through from scratch, but essentially what happens is you get all these lines that are they're not there yet, and then
Well, it thinks it should go, and then you
Yeah.
finalize it.
you have to draw this, for
Gotcha.
instance, this red line. So if like this was gone here, I don't know how to delete it.
I got you though. It shows what it thinks it should be, and then you finalize it.
Yeah, you have essentially
Confirm it.
it only shows you this. You have to do what I'm doing here, where
Yeah.
I'm like connecting this. It just shows you a straight line, white line that is like tells you that, oh, this one needs to connect to here, but you have to connect it and you have to route it and do all the angles. And so it becomes a little bit of a puzzle, solving a puzzle. It's fun, what you'll do, because you'll have all these wires, right? And they'll be crisscrossing, and what you can't do is you can't cross, for instance, the red represents the first layer and the blue represents the second layer. So you cannot cross a red line across another red line, because that would be a short, unless it's you want it shorted. So that means you end up with situations where you cannot get from here to there, right? And so what happens is then you want to use your second layer, or you have to like see how I routed this one around and kind of through. You'll have to do that in order to not crisscross. And then what you have to do is use the second layer, the blue layer, to do the other ones that you couldn't do with the red. And then on top of that, you may have to do what's called a via connection, which means that I needed to go from blue, switch to the red plane, and then to finish, because you'll see this blue one crosses all these reds, and then I switch to red here because the blue is in the back plane, and I need to be in the, I guess I'm not sure why I did red there, but occasionally you'll have to switch. And like here, I'm in blue crossing these reds, then do a via hole through, go to red, and then back to blue, because these pads are on the back side, so they have to be blue. I think I needed this red side because it's on the actually I don't know about that one, but so that's the idea, is you do all that routing, and it's a puzzle that has to be solved. And then you make the mistake of flipping around this connector upside down, and then have to redo it because you realize A is supposed to be on or 1 and A is on the left. To show you what the different layers look like, for instance, here you could switch to the B layer, or there's the blue layer there, and then the red layer is there, so you can, and then you can actually turn off, let me get rid of these things on my screen here. You can turn off the some of the layers by clicking over here. Right, I can't really see it. Oh, is it this one? Yeah. So you can, that's the blue layer and the red layer off. So you start, and then the silk screen is you start learning about all the different layers that are involved. The main one being the silk screen, which is the writing. There's a front silk screen and a back silk screen. I'm not cooking the wrong thing. There it is. And then there's a paste layer, or well, that's not as important. There's the blue and the red traces. And then, of course, the edge cut is very important. That's the edge of your board. So you have to design what your board looks like. That it doesn't have to be a square. You can use polygon, any polygons. You can make circles. So that's like very important to generate all that. And then when you're ready, well, then you can run a check on this. This is the most important check, the design rules checker. you run this, the GRC, it checks everything and, you know, give you any warnings if there's a problem. This, and like errors, warnings. This track is unconnected, and I'm not sure. Somehow I graded a warning or an error by whatever changes I did, but it'll show you any problems that you might have encountered, and then you can go fix those. So then the next step after you've verified everything is you go ahead and you generate the Gerber files, and that's done by Gerber's fabrication outputs. And so you generate those, and then you can upload them to a, oh, I didn't show you the one more thing is the view of the 3D view is very convenient. You can actually do the 3D view of the entire board. And this is kind of what it looks like. Now I used sockets for some of these ICs, and it is a little bit of a pain. Like if you want to show the actual chip in the socket, there's only one footprint for each symbol. So I mean, people are doing it by creating a separate thing, but and for this I didn't. That'll be a more advanced, you know, class or whatever. If I do that, I want to make the board look really perfect. But this is what a chip looks like if there's no socket. And this is that audio component I imported from the internet. So, and it, because I wanted to see what it looked like, and I, in fact, originally had it reversed. I didn't know where the connector, where the actual socket was, by just looking at this outline. They call this the porch, front porch or something, or these areas that are the areas that you should not overlap with any other components. But yeah, that's kind of really neat to be able to visualize, you know, before you go any further. So there's that. Okay, we'll start.
So Jim, out of curiosity, why did you only socket 2 of the 4 ICs?
I was gonna ask the same thing.
Oh, well, basically I did that because the original design that you saw, they didn't bother, and the fact that these ICs are resistor arrays. So, and the other ones are actual, you know, semiconductors.
So you worried about heat damage when soldering them on or something?
Yeah, well, I mean, theoretically, I mean, I copied what they were doing because I figured, well,
Yeah.
if the buffer goes bad, you can replace it because it's a silicon, you know, it's a something that could get ruined, it could broken by static. Whereas a resistor array, I don't think
More
so.
robust.
Discrete component.
It's a discrete. These are ICs technically, but it's a resistor array. So they're just, you know, 47K resistors in there. Is that really going to need to ever be replaced? Probably not. But that's my logic to it. But again, I copied another guy's design for that, and I don't want to make any changes to that. And so, what are we looking at? Okay, because I'm gonna that time here. Yeah, you can see here they didn't bother with the in that case. So then I guess I can close. Right, we saw that. Let's just close these PCAD things. So there's but you can customize where you know, in my case, I had to customize a little because there's components that weren't there. Now also, okay, so the next step is you go to your favorite company that does boards, and JLC PCB I've used before, that I was given some Gerber files, and I just uploaded them and had a board made, you know, so that's cool. And now I had my own to make, And you can see, yeah, here's my order, and they even give you a preview of what your board is going to look like after you upload the Gerber files. And you can see it cost me $6.40 to make 5 of them.
It's a good deal.
$20 shipped, $21 shipping, and from China, and it came in less than a week about.
Wow, that's
Unbelievable.
crazy.
All the way from China for 20. I mean, yeah, you can get it. There are more expensive places, definitely, but
Is it made it from China?
And the quality was
made in
good?
China. Quality's pretty good. Yeah, I mean, these are thick. You know, I mean, to get this price, you have to use just the basic features, the 2 layers and not a lot of copper or whatever it is, but it's good enough for hobby projects. I mean,
Can I pass that around?
yeah, pass that around, please.
I think that last part, the production part is what everybody is excited about. And we'll see. Like, oh my gosh, you can do it for $6.
Yeah, it's just the shipping is the only,
Sure.
oh, and like one of the, you can see like, yeah, this is the component I'm using, and then one of these, just to show you one of the audio.
So it was a little over $1 each.
Yeah, really, and that was,
Pieces, right?
yeah, so this is that piece that goes in,
There's your audio jack.
yeah, like here, this goes in like that. You can see that, of course, then I'll have to solder these up. Yeah, I want to pass this around. Pass this around. That's part of that. And so, yeah, and then, so that's a pretty easy process to order it. You upload all your those Gerber files. Well, the one thing I didn't show you yet, you generate the Gerber files, you store them in a directory, and then you can even view the Gerber files within this tool as well, just to do a sanity check, which is recommended by the production facility. So if you go here, you can go to your Gerbers, open them up, and it loads them all in here. And you can see this is what it looks like. And you also generate a drill file, and they specifically really want to know, they want to make sure this is all correct, because this is how they drill the holes. And I did make one mistake. I was looking for I was trying to make a pin two test pins of 1 millimeter size, the normal ones you have on your Raspberry. And I chose what was 1 millimeter, but that was the outline. The actual hole is 0.5 millimeters. So I have to find pinouts that are 0.5 millimeter in size if I want to use this. Yeah, I want to do this so I can hook up my oscilloscope to monitor. I want to see the waveform of the output. But hopefully I can find a very small pin. But when you're doing when you're choosing the component, you may want to measure it with the measuring tool to make sure, because there's so many choices in there, and you don't know when they say 1 millimeter, 2 millimeter, what is the 1 millimeter measurement for exactly? Is it the hole or the outline, the whole thing? In this case, it's these two here. And it was, the whole thing is 1, but the opening is a 0.5 millimeter. So anyway, and then, for this, you can also turn off the different layers as well, the different copper layers. This is that's the ground plane, and then, here, if I do that, there you can see turning off different planes. Same thing, but so you can do a final check there before uploading. And yeah, believe me, you want to check a lot of times, because I still don't know if this thing works. So we'll see. Yeah, I think that might be it for that.
One thing you could do, Jim, is print it out on a piece of paper and put the parts.
Oh,
in
and
the holes.
Yes, as a matter of fact, I did do that. Here's what the paper looked like. And I did this specifically to check, these pads, those pads there are for two connectors that go into a back of a computer. And I had no, I had to measure the distance between those two sockets. And so then I printed this out and literally went up to the computer and held it, and it was off a little, and then, so I moved a little bit and I discovered, hey, it's exactly 10 times the width, the distance between each of these. I knew the distance between each of these pads from some documents, but I didn't know the distance between the two actual connectors. And so it turned out it's it seems like it's exactly 10 times that distance of between. So I'm like, that seems right, I'll go with that. And so I have yet to know if it really truly lines up. But there's a little leeway, because I can solder a little bit off, if it's a little bit off, like tenths of a millimeter, Anyway, so any questions or comments on that section before I go into 3D printing?
No, just that the layout portion of it is for me, that's where science meets with art. So your schematic describes electrically how everything fits together, and you draw your schematic out in a way that visually makes sense, right? And then the metal meets the road when it's time to lay it out on a board, because now everything has to connect and things can't cross. And the design decisions that go into, like, some things are fixed. Jim's connector has to go in one spot in one dimension. But then where do you place your components, right? So, like, the feng shui of the board may suggest, where you want to put them. But at the end of the day, it's where you have the least amount of vias. And so you set them where you think they're going to go. And then you start laying out the leads. And after you start doing that, you're like, oh, well, that doesn't work out. And so I'm sure, as Jim went through it, he may have made some adjustments to where he thought they were going to go. And the tool does sometimes it works out well. Once you have some of your lines laid out, you can still drag the component, although sometimes when it attempts to solve for your existing leads, sometimes it works out well and sometimes it doesn't. But yeah, it's if you're not easily frustrated and enjoy puzzles, I think that's the most fun part.
It really was kind of a fun puzzle because you're building, to me, you're building something as well as solving a puzzle. So yeah, as long as it's not as long as you don't start with something too challenging. This one is probably beginner level, I think. So it was reasonable. Plus, I had a design previously made, so. I think that's the best way to get into this is take some, only do part of the work. If that's, find something that's, part is already done for you, like the schematic, and you don't have to, you can, do it quicker, obviously. So yeah, I agree. But so the next, or for the remaining time, I'm going to talk about some 3D printing design through Fusion 360 that I've been doing, and some pointers that I still am discovering. I'm still learning Fusion 360 because I've never really taken the time to go through long tutorials, and I don't know, I kind of like learning on the job, I guess, at least for that software. So here I had show you a situation on my robot Big Orange where I have the this microphone array, and I really want it nice and centered on top of this display, but it really needs, this is just taped there, and it's on an angle, and I want to put a kind of a seat here for it, and luckily there's actually a screw. You can see this is rotated, but right there, I've taken the screw out. So that screw I'm going to try to use, and it's a long screw. So I'm going to try to use that and secure a platform for this to sit in and to be secured. And I'll show you, I just started that design. So here's another very quick design I made for a household item, really. And this, I'll show you, the cool thing about this is I just learned how to do particular follow a curve and make an extrusion along a curve, basically, or a path. But this little device here, I invented to hold a toilet seat to the toilet top, because when you install, sometimes you might install a toilet seat with a padded top, and the top won't stay up when you put the seat because there's not enough room or something. And so this little device clips the seat with the top, and then it doesn't fall. Very convenient, or very important.
Functional print.
Yes. Here's another one I'll show you the design of. This holds my lower motor for the camera. This is the left and right axial. I don't know what the right term is, but this I combined. What's cool about this is I found a normal servo motor mount on Thingiverse, and but I needed to take it and build a platform that would screw into my top of my tower. So I actually, so this, I'll show you a quick example of taking and importing a mesh and then merging it with your new piece that you need to secure it to your new application, basically. This next one is, well, that's the final look. I need a seat to hold my speaker on the robot. I'm just tired of it falling off. And luckily, again, I can't recommend this more, this platform I bought, the big orange HCR. It has so many screw holes and connections that there's just enough for everybody without having to drill much. So this one, I designed this little tray and to hold the speaker. And that was, no, these are not very challenging designs, but so practical. And okay, so now let's go into Fusion. Oh, and there's this one. I didn't take a picture of it because I have it in person. You can pass that around. So I needed, so here is my charger base. And it sits a certain level off the ground, right? And it is, I designed it, or this is a vacuum charger, but I've adapted Big Orange to use this vacuum charger. But it needs to be at a different height on carpet versus hardwood floor. So I needed a riser. So that's what this came in. This need came in to make a riser. And so let's see, how do I get rid of this? All this stuff on your, okay, close that. So so I designed this riser. I employ some very basic tools designing, which you probably are familiar with. The protractor, okay, and a high school compass, okay, because that's great for figuring out the circumference, or for the diameter or the radius of some sort of circle in your, whatever it is. I end up doing a lot of adapting. I guess all these are examples of adapting a new piece of plastic to an old piece of plastic, to an existing piece of plastic or metal. And so this was that situation. And this one's not very complicated, but of course I do the normal thing. I got in the habit from Alan's original classes at Riverside, is to design your drawing, do your sketch, and measure everything, measure very carefully multiple times, and then you start to lay out either top down or front view of whatever it is you're designing. And sometimes you can just wing it, like if you don't care that much, like in this part, I don't need, you know, I need this round part to match pretty accurately, but I don't care so much about the angle as long as there's some of this detail. You know, so then it may not be exact, but it's not that important. I just need it to not go out too far because you know, in this part, I wanted this to be pretty accurate. So the robot doesn't hit anything when it comes up to it. And then the only part here is, so then I did an extrusion to bring it up. And then, you know, from the sketch, it's just a sketch there. And then I extruded the pieces necessary to bring it up there. And then just rounded off the corners there for fun, chamfer. So that's it, and that's it. It's printed, and you're ready to go. That toilet seat holder thing, it's pretty. What was cool about this is I learned some. You always seem to learn some critical things when you're doing this. I knew about what's it called here? The revolve, not the revolve tool, but the it's the, which one is it? Let's see, hold on.
Here, click on the word create, they'll have access to additional tools.
Yeah, it's the sweep tool. It's called the sweep tool, and you can see that picture there where it's like making a pipe. And so what I did here is, let's turn on both sketches. I made this closed, this outline, or this sketch here. This is a sketch of this sort of a flat tube, whatever, and then did some rounding at the corners. And then I created another sketch with this this curve here, the curve I wanted it to go. And then here, what is cool about this, so the history, I can just click this button and show you. Now, I then use that sweep tool to sweep it out that way, and then sweep it out that way right along that path.
Wow.
Which is really cool, to make a really kind of a complex looking object. Now, then I got into trouble because I kind of forgot, or I really hadn't dealt much with surface stitching and all that. So to make this thing isn't really a body yet that you can print or that you can export. So this stitch tool is very, surface stitching is very critical part. So this, I selected these different surfaces and then ran this, just executed the stitch. You can see the ones I selected. Then the thing it's becoming a solid object eventually is the point, but it wasn't not quite done yet, because then the next thing here was I needed to put a surface patch, because when you do that sweep, you end up with literally a pipe, right? Remember, it was a pipe. So there's no surface here at this set. This is like clear through, nothing there. So I had to add these two surface patches. So now it's closed. Now there's a patch there. And then finally, I had to then stitch that those patches, to the other body to make a final body. And then the last thing was I wanted to cut off that bottom. And this one is still there. But so then the final thing, you cut off that curve. So that's that one. Not too time consuming, but it employs some cool features. And then here, this one, has a cool feature with drilling holes. Because in this case it's a recessed screw, and I actually used a drill to actually put in what do you call it? The actual threading. So you can see here, this again, not too complicated of a design. Started with the sketch, which was just, yeah, a pretty simple sketch. And then after the sketch, did an extrusion. Let's hit the right button here. So that's an extrusion. And then brought up the edge as a nice feature here to do just the do an edge extrusion. And you can even flange it out. I'm just amazed at the features. See, it's flanged out a bit, and that's all part of that one command. And then this one was, oh, I made a plane there. Another sketch, and then this is the, yeah, a plane to make the holes, and then drill the holes. And that's this part. And what's cool is you can pick the actual screw type and everything, which is really, that's really important. And I had, you know, a 4mm M4.7, and it has everything you kind of need here, all the dimensions for the top, you know. And so after working with this a little bit, it's like, wow, this is really powerful. And that one command, that one drill command made that whole double hole, multiple, the pilot hole, I guess, and then the threaded hole. So, yeah, and then, the pan tilt mount, that's the last one, I think. And I'll show you briefly, I can show you the latest thing I'm working on. So here's this one. This one had the most steps so you can see the final thing is this bottom part is my own design that fits on my robot and screws into the top of that mast. And I actually used that for a previous version of my motor mount, which I had these 9-gram motors. So I upgraded to these full-size servos, and so then I imported this part from the internet, and it was a mesh initially. So that's what's really cool, is to be able to take, because I'm frugal in my time, and I rather just import something rather than design it from scratch if possible. So like this design I had to make from scratch for my base, but and I even imported a bunch of these steps here or I actually took my old design and just deleted some of the newer steps, and so all this part of the design is reused, but this is the new part. So I brought in a mesh from the outside world, and then I move it into place, convert it to a body, which you can do, and then you have to go through a few different steps here. Mesh repair, I did a mesh repair, mesh reduce, repair, convert the mesh, that's the sort of critical one, which will convert it to a body, then move it into place. This one, okay, I got a plane there to cut it. And oops, what did I just do? Get back to there. Let me stop this thing. Not the stop button. Okay, next, and then I cut it, and then move those down, and then what's this last part? Align. That was a sort of critical thing, to align these. They were just slightly off, and so the align tool, I moved it so it was perfectly flush, and then I beveled the edge, combined this all into one body. So now that's a single body, and ready for export. So that's a case where You know, I combined an old project that that I needed this base and then this imported stuff. So that's that. Let's see, is my new speaker mount. What's the one I just was working on? Yeah, the speaker mount. I don't know. Hopefully that is available because it's spinning here. What does that mean? Might not be able to get it, but this is my latest one, which I have not printed yet or even finished, and it's a little bit of a challenge. Like you saw that angle, I measured it out as 21 degrees. That's back to that picture I was showing you.
Did you use your protractor for
This
that?
here. Yeah. Well, I don't know. What did I do? Yeah, I used the protractor. That's exactly. So to get this angle and all, so this is I don't know if this is the best way to do anything, but I just felt like, all right, I'm going to try that. This is kind of a cool thing to try to print. And that's not loading. Maybe let's try loading something else and coming back. This one I just saved last night from my desktop, so I'm not sure what it means.
This might be one where you could cut out paper and see if it fits at the right angle, as a double check, a little wedge, because that's what you're basically doing is a wedge, right?
Yeah, it's kind of neat about that one I did some cutting. I had to create a base and then I'm doing a subtraction of objects there to create the angle, to create that what fits on top. So I modeled the very top of that monitor. That monitor is a rectangular object, and then tried to make a base, and then subtracted one from the other so that it would end up being the part that fits on top, right? Yeah, I guess this may not work. Let me I'll put this, and we'll take some questions. Now, in case I do get this to come up again, so those are some of the tools that I've been using in Fusion 360, and I think it's it's a learning situation every time, it seems like, for me, but it's rewarding. So anybody questions, comments, suggestions for that? I was gonna ask if
That's a lot of fun stuff.
yeah, so that's the same as my alarm at my house. I have for my IoT alarm. Let's see if I can load this. Yes, speaker now. Okay, it's coming up.
There we go.
So this is my latest incantation. You can see this thing is supposed to fit on top of that. And I started getting the hole for the screw, but I have not finished that. And again, this started with, I just did this last night. I started with that. I made this what do you call it? A sketch of the kind of just a part of the outline of the top of that thing, and I rotated it to 21 degrees that I think is right. Of course, that's variable. The monitor moves, and then made a plane here. Then made this. Now this is the outline of the actual. The inner one is the size of that speaker array box, that white box, and the outer is the size that I want the platform to be, so it's slightly larger. And then I extruded that to make this is sort of a dummy object here to represent the object's going to fit. And then what was this one? Another sketch for the, maybe for the, that was for the hole, I think. And then here, then I extrude that to create the base, then downward as well. I had to cut it in half, so it's just downward on that side, because I don't want to go more than 5 millimeters on this side, because then you'll start blocking the monitor. And then I joined those two objects, and then I did that subtraction that essentially of the object below. So now this thing should fit on top. And then the last step is to extrude. That's trying to drill the hole. Again, I'm not quite done with that hole, but that hole needs to go in at this angle. So it's going to come out. It comes out here with a recessed hole in it. So I'll have to finish that off.
So that's like at 111 degrees.
Exactly, yeah, 11. But I was like, sometimes I come into this thinking, oh, I don't know how I'm going to do that. And then the tool like seems to provide a way after like solving a puzzle again. All right, well, thank you.
Thank you,
That
Jim.
concludes. All right.
All right, we'll take a lunch break. Do you guys want to come back at 12:45? So we can have 15 minutes to do our business meeting. All right, we are back. So if everybody's ready, we will continue the meeting. Ron, so this is now the business meeting, and we usually always start with our treasury report from Ron.
We have $10 additional, so it comes to $1,060.44.
We didn't have any expenses this month.
No expenses.
Okay. For next month's meeting, Alan, were you gonna give a next talk on, I think you said, Henry?
Yeah,
For that?
yeah, go ahead and put me down for the 10 o'clock slot. I'm 50-50 on an introduction to Docker or whatever
Oh,
I'm
yeah,
working
yeah.
on for. And I'll decide over the next 2 weeks if that's okay.
Yeah. And Jim?
And now you.
You said,
Yeah, so it's, I talked to Bob Barbosa, and he's tentatively wants to fulfill the 11 o'clock next month. He should be able to make it because his contract is finishing, and he says he has the time. So now, and I'll give a little, during show and tell, I'll show his webpage as a preview, but there's a lot of stuff going on that.
so should I put Bob on for 11?
Yeah, put Bob on for 11. Bob Barbosa's Space Institute.
Okay. And that's tentatively, or?
Yeah, it's tentatively to be confirmed towards the end of the month, this month.
Okay.
But he should be able to make it. We'll confirm at least a week, 2 weeks ahead, I think.
Okay.
Then and I would fill in. I could probably fill in if he doesn't.
Okay.
But he should be able to this. And it's a lot of stuff, exciting things.
Okay, so, we had some invitations to different events, but unfortunately, a lot of those were in the middle of the week, with very short notice, so we couldn't make them. Besides those, I don't think we have any other events coming up. Are we good?
Yeah, well, we don't have, not confirmed, but did you see that email I sent out about the Maker Fair? The Maker Fair coming up, Orange County Maker Fair, unbelievable, at the OC Fair complex, OC Fairgrounds. And I think is it September? So we should think about going to that.
Will they give us a table?
Yeah, and you can get a table. It's a free event.
Does that mean we get free admission to the fair? But we have to pay admission to the fair and to but a free booth?
I think you probably get free if you're part of the, I can't remember the details on that, but, I could, yeah. I can actually share that in a minute. I could bring this up,
I was planning to go to the fair anyways, so I would totally do that.
yeah, I mean, it seems like something we've done in the past, right? That, we definitely could do again. You know, because it is it's a great venue for us to reach out to people.
That's a ton of people.
Yeah, and it's back again after a few years, and then the Orange County is the closest one ever. I mean, usually it's in San Diego. And then there's DTLA as well, the downtown LA Maker Fair or Mini Maker Fair. That's coming up next year. They're planning for next year, 2023. So that's a little further off, but still only like 8 months or something.
Yeah.
So that we could plan. I mean, it's never too early to get people interested, right?
Yeah, I'll be interested.
Right, here's the Zoom. So, yeah, Maker Fair, Maker Fair, Orange County.
So put this down. What's the date?
So, Orange County Maker Fair, let's see. I think, yes, it's supposed to be September something, or is it? Okay, September 10th, 2022. It's on Saturday. Oh, and it's our meeting day. So instead of our meeting,
We can stream it from there,
we could go over there. Yeah.
Oh, that's good.
but how would we stream it? And that's-
Well, I don't know about streaming. Yeah, I didn't think about that, but
They might have internet for you.
Well, can we record it or something like there and then stream it later?
So it's September, we still have some time to think of logistics.
Mhm.
But
Yeah.
it is possible, we can do something with it. That's if everybody
September
wants to do
what?
it.
September 10th, here's the page here. And yeah, now to actually participate to have a booth, there's going to be an earlier deadline because September isn't that far off really. So we'll see. I don't know if they have that kind of the booth. You have to yeah. There's a call for sponsors, call for makers. That's for us. Exhibit applications. So exhibits are not approved in order received and may take several weeks. Okay, blah, blah, blah. Apply now. I don't know what they don't seem to have a deadline in here.
At the fairground.
Yeah.
That's huge, right?
Yeah, it is huge.
Yeah, well, they're probably not using the entire fairgrounds, but it's,
One of the buildings maybe.
yeah, it's just a smaller, this year we will have 2 buildings and outdoor. And the outdoor space is covered promenade between, so technically considered a building. So here, yeah, here's the details. Yeah, it's only costs money if you want to sell anything, $100 seller fee, but otherwise
so-
it's free.
So
And
we have until the 9th of next month.
sign up deadline is this, yeah, there it is, fine. Yeah, so that's why we need to think now.
Yeah,
Will it be
This-
here in September?
And let's see, I don't know.
wait, the 10th is on Sunday.
Oh, is it a Sunday? Maybe I got it wrong. I
Oh, no, no, never mind.
thought it was a Saturday. It looked like,
Yeah, it is a Saturday and it's our Saturday.
yeah, because it's it's the second Saturday of the month.
Yeah.
So whether we could stream from there, yeah, that would. Now I do have I have an iPad that has LTE, so and I streamed from Northern Cal with it once. And if I have enough data left, well, that's early in the month. I probably have data, or we could use if they have Wi-Fi. Good, then we could.
Okay, so if we have enough people, like say maybe at least 4 people, let's do it.
Yeah, what is the minimum? That's a good point, yeah. Four is
Because
like
if
a
it's
good,
gonna be two or one person, two people going, not really.
yeah, I was wondering what the threshold is, what you feel the threshold is. I was like, at least, you gotta have at least 2, 4 is probably the proper, because, yeah.
Otherwise, I mean, it's gonna be two
It's a lot of
guys
work.
at a table.
Yeah,
A lot
I
of,
live close by, so,
it's a lot of setup.
You wanna go?
yeah.
Buffet is interested in going.
You wanna go?
Yeah, I wanna go.
I'll
Oh.
probably go.
Okay, I mean, as long as we have, at least 4 people bringing, stuff.
Mhm.
Yeah, this by go, we're talking about going to
Bringing
the
stuff.
booth,
Right.
Yeah.
Yeah,
showing up at the
You know,
booth.
Something. at the booth.
demonstrating.
Yeah, you know, how much space we got or whatever, but yeah, this application we can fill out.
I mean, I say go for it.
Yeah.
If we have the people that are gonna be there bringing stuff,
Yeah.
And yeah, I would bring stuff, obviously, I definitely bring mine.
I've got lots of parts.
you wanna bring parts, you're a 40-pound wizard, power space.
No, but I mean, I got a bunch of, you know, the wheels and the thing, all the things that you need to put together, that kind of
Okay.
stuff.
Yeah, whatever.
You know, there's some easy projects that I learned, like the robot hand, you know, with you just use a paper plate and you cut the hand shape and you have the little straws and you tape it and then you can make it,
Mhm.
right? So maybe we could come up with 1 or 2 easy projects.
I mean, we can section off our booth for like beginners with that kind of stuff and more advanced stuff.
Yeah, I think we would want a nice amount of space.
Jim, since this was like your find and you wanna submit our application,
Oh, yeah, I don't mind doing that.
And you live in the area anyway.
see if you can get us I don't know how big a table. or
We'll have to figure
tables.
what this all out, like, we want a booth or exhibit. I assume that's that main thing here, the first choice.
Does
Yeah.
anybody in the group want to sell? Maybe everybody who wants to sell can pitch in?
No, we're
No?
not gonna sell anything.
Oh, okay.
We don't, and
No.
nothing to sell.
It just,
Type of booth, this would be, individual maker or group. I assume,
yeah,
yeah, the rest, or nonprofit institution.
yes, that's
I
more. us.
wonder, oh,
That's
that's us. I wonder what the difference is, and, well, maybe they just need to know legally, I don't know. And then project name, which is, would put a,
Robotic
RSSC, basically,
Yeah,
full description remains private, oh. Okay, we could just, people who you're gonna bring, we could just talk about, well, I could just put a generic thing here, we will show our robots, of different kinds, Lego, all the way up to custom, you know, whatever.
AI robots.
AI robots. And this is the public one. Well, then I'd do almost the same thing here.
Yeah,
If anybody, well, if people want to email me or the group or something, what you're gonna bring, that would be good. Then I'll kind of summarize. And then a project photo.
and it's required.
Yeah, well, we do have photos from our webpage. Or we could take one, well, yeah, how we're gonna, we could take one right now of his stuff. He's got a lot of stuff there.
Yeah, but that wouldn't be the only stuff that you bring in.
No, I mean,
Like-
Yeah.
take a, do a composite. Like I have one of orange and me and,
There's a lot of stuff in
the
our
stuff
website.
on the
Yeah, I would
aquarium
say
picture.
Guys.
now.
Guys, I gotta go. I'll see you next month.
All right.
All right, Tim, see you next
Bye,
month.
Tim.
All right, well, this doesn't look too difficult. What are your plans? This is all basic. Oh, here we go. Space size. Standard booth is a 10-foot by 10-foot.
What happens if you does it? drop
10
down
feet
if
is
you-
not very big.
What
that's
what
like
happens
2
if you
people.
do other, non-standard does it like give you,
Yeah,
there we go.
That's
Nice call. How did you know?
That's a booth space.
Yeah,
What about a table?
I know, but see, it has that other one.
Oh, you're asking, does it come with a table?
No, but see, if we do the other non-standard, we can put whatever size we want.
yeah, I would
We
say
could, yeah, we
10
could.
by 20.
Yeah, what do you, because I'm not familiar with sizes like you're saying.
Well, 10 by 10 is like,
Pretty small, huh?
yeah, like.
It's like
this one,
two of these tables?
Two
or
and a half.
2.5.
So that's not very much, you know? If Jim comes, he'll use up one side, right? You'll use up one side.
Hey, yeah, you need,
So you need a 10 by
you
20.
need like at
minimum.
least 5 feet per person, right?
Mhm. So I think you need
almost
a
not.
10 by 20.
So we're
Okay,
gonna-
so I could put that down. All right,
If
good.
you want to have activities like racing activities or something with your robots, then you need bigger.
Oh, there's location preference too, inside, outside, either, lighting, normal, dark.
So in September, that's gonna be hot.
Yeah,
Mhm.
Let's go inside.
Inside.
We have a lot of 3D printed stuff that might melt.
Yeah, and we want electricity.
Smart. All right, let me go back to where I was. Okay, so I'm not gonna do this now, but you say, length is 20 and width is 10, right?
Yeah, at minimum.
We could ask for more, I don't know.
Well, the question is, do you, yeah, you know, you need to do an evaluation. Is there gonna be something, like, see, they have this competition bit?
Yeah, that we're not gonna, obviously,
Okay.
we don't need the competition pit. I mean, that's for,
It could be the fire competition. Oh, well. what-
this is probably some, no booth needed, okay, standard, okay, so, and then, non-standard setup, all right, I don't know if we need that. The booth layout, optional, okay. Hands-on activity, yes or no, okay, we can decide that.
There, yeah, make
Probably
appears
no.
like hands-on.
If you guys have one, you
I'll
can
make one.
email me. If you
I'll
want-
do that. I'll do
Okay,
that.
that'll be a yes then.
Yeah.
Inside preference, lighting, normal's
fine.
okay. We're not gonna do it. We're not gonna do a follow the line contest, that's for sure. Where the lighting would like screw up the robot. Noise, normal's not interfere. Oh gosh, I would prefer to be,
Normal.
No.
That's how much noise you're creating.
Yeah, I think normal.
Yeah.
oh.
Potentially annoying sound.
Wow, oh, I see.
That's the big buzzer,
Yeah, so we're not, yeah. generally.
but you absolutely want
absolute-
power.
Yeah, of
Yes.
course. That's for sure. Oh, gosh.
Laptops, robots, charging robots.
Just make sure you put, provide outlets.
Oh,
Usually
well,
they'll
that's
give
what
you
they
one.
mean by that, right?
Usually they'll give you one, you have to take your extensions, right?
Power strips, yeah, we always bring power strips. There's a lot of, setup for this, isn't there? Oh, essentially no advanced specific amount you need. Oh boy, this is getting complicated then. I go for 20 amps. No, that's about enough to handle Alan's double 3090s. Just for speech. The rest of us can have one 5 amps.
See, must have Wi-Fi internet access,
Oh.
right?
Well, yeah, I mean, I don't know if like mine doesn't actually, but
It would be nice.
because my robot now can do speech with no internet. That's why I did it.
But if we have access to the internet, we can stream it straight
You
from
can
there.
stream, yeah.
Well, you want to just leave it at nice then, or you want to do for, I must have. I wonder if this is all free, why wouldn't anybody just pick the best thing of all these choices?
Yeah, I'm guessing that at the end, it might give you a prize or something but hopefully not.
A prize?
Like
Price.
for power, this and that.
Oh.
It
It's gonna
said,
be-
I don't think
oh,
so.
maybe it isn't free to,
Well,
wait, no, it said up at the top, it was free for unless
You
you're,
know, so here's what happens is they either accept you or they don't.
oh, maybe that's
And
it.
if your value is not high enough, to justify all the things you check, then they'll say, no,
Okay.
this club has value, so.
This is, you make use of fire, and no, I hope not. Not if the batteries are working.
What happened to, it worked at home?
No, not really, no.
Climbing its equipment. Did you produce any waste? I hope not. Batteries. Oh, next, God.
But wait, there's more.
I hit the wrong one.
At least they let you save it.
So Orange County's gonna have a maker fair this year, huh?
No, I'm gonna have to
Yeah.
fill all this up before we'll let you go to the
Yeah.
next.
So,
Now, yeah, we don't know, yeah, so anyway, I'll have to do this later.
What's the date on that one?
This one's
September 10th.
10th, September.
but,
September 10th, all right.
the sign up is, next month on the 9th, the deadline.
Okay, thanks, Ben. Yeah,
We have to.
should go
we
to
have
that
figure
too.
it out. Yeah, Riverside wants to come. Yeah, you guys, yeah. I'll paste this in the chat here. Oh, not that.
If I can keep the benches for until then I'll bring those too. I mean, that could be our interactive.
Chat. And then there's, the other one was the DTLA, Maker Fair.
Is that in December again?
That's gonna be, no, April 1st, 2023. So I know it's a ways off, but I figured I'd just mention it.
Sure.
Because I wanna go to that again.
That's a
It's only-
fun one.
Yeah, they're doing it in April, whatever reason.
And the last one I was there, driving back home, getting through those little streets.
Oh, it was,
there
yeah,
was-
did you end up going in circles trying to get out of there?
I did, and then,
I remember.
let's say transient, like was walking just like in the middle of the street and, I was at the light and then slaps the back of my hand
Shoot.
and,
Oh, that's scary.
yeah, yelling, and I was like, what? And then.
LA, am I right?
LA, it's an experience, and that was before COVID.
And, yeah, it slapped it really hard. I thought it broke the window, but no, it's just like, oh my God, what the hell?
And that didn't happen to me. I usually just get lost, even with
Yeah, that's kind
GPS.
of like, yeah.
It's fun. Yeah, Walter really liked though. I mean, he was a big fan of the.
Oh, yeah, there's just the orange right there.
Oh, that's his.
Yeah, that's his orange.
Walter's right.
That's orange, that's orange right there.
There's no other in move that looks like that.
No.
That's funny. We
They've
just
been
mentioned
using-
him, and he
They've
comes
been
up.
using that image for, I don't know, like 5 years. I don't know how many years.
Yeah, and my vintage computer people have come to that show too, which is like I get a twofer because I'm a vintage computer nerd. Yeah. Anyway, yeah, I look forward to this one, and that's really close. Well, but Orange County's even closer. Anyway, so that's it for that. Well, send me any info that about what you want to bring. Or if you browse this website and have better answers.
I just asked the pitch people if they want me to do that.
And I swear it did say it was free, right? But yeah, you may not get your power and all that if you're, if you're not, you don't pass their whatever criteria.
All right. This is still the business meeting. Is there anything else anybody wants to bring up during business related?
Have we done announcements yet?
I guess you can do announcements now if you, what is it kind of business related?
Just Riverside's meeting next week, and we're gonna have our wall following contest.
Okay.
And we
Thomas, if you
see
want
some
to-
people besides Alan that come out and meet.
If anybody wants to participate in the wall following, it's the Riverside,
That sounds great.
next Saturday. Is it the same library? What is it, Hillcrest or what is it?
Woodcrest. I'll put it,
Library.
I'll put it in the email and the chat.
Thank you, Thomas.
If anybody needs a robot, I have all the parts. So if you needed something or needed code, just contact me. We're lending, selling parts as people want. If you want a loan, we just ask for a deposit.
All right. So if, no other questions, we'll, continue with the show and tells. Which, Faye, you're up next. You're the first show and tell.
Okay,
Yeah.
you're up.
You're up.
What?
Yeah, you're the first show and tell.
Okay. So,
You want to introduce
you must
yourself?
stand?
Yeah. You don't need to stand.
Up to you.
Okay.
I mean, it's up to you.
My name is Guo Fei. I'm from China. I am a STEM teacher.
Stand, yeah.
Yes, I teach some students. Teach students participate at LO, First Lego League or WRO. Yes.
Thank you.
I focus on the Lego and AI program. So this is my project. This project is face tracking. Face tracking. So this is Raspberry Pi. Some AI OpenCV program running on this Raspberry Pi, and Lego EV3 control all the motor action. So when the camera recount the face, so the face on the screen position through the Bluetooth to the EV3. EV3 program and run follow the score, control the motor left, right, up and down.
So it follows, it follows the face.
Yes,
Follows
follow
the
the
face.
face. Yes, follow the face. Yes, I can show you.
Sure.
Okay.
This is demo for.
So he created an interface with the Raspberry Pi so that the Pi could feed the EV3.
I can, so, the Raspberry Pi can.
Sends the messages to the EV3.
EV3, but the Raspberry Pi is needed because to do this other sensing stuff.
It does
Okay.
the sensing, and then it sends the message to move the motors.
Okay. Because the EV3 alone is not really practical to do that, right?
I don't think it would even hold the face recognition.
Oh, right.
It's too big.
EV3 is, yes. Man, I was impressed with the NXT processor, even the old one, how much code it could hold, you know. But an EV3 is better, but it can't do that level.
So, and this is a EV3 speaker. Okay. This said I am a AI Lego robot. I can tracking your face. So
In
this
Chinese.
screen, yes, the Chinese, yes, in this screen.
So that,
What is it saying?
You translate it.
What's the voice saying?
What's the
saying?
voice saying? Okay. Hi, hello. I am facing tracker. Sorry,
Oh,
I'm facing tracker Lego robotic.
oh,
I can see you. Or if some face recount on the screen, the Lego said I can see you. If no any face, they can bye bye. Okay, okay. One when the Lego when the Raspberry Pi recount me no more face. It's special my
stick
face.
to yours.
Yes, they can see you are teacher John. So this voice is teacher John. This actually is teacher Wu.
Okay.
Okay. So this is all the project.
About
This
the
is
next one, homework.
this is Python run OpenCV on the
Running Python?
Python, yes, it is. It is Python on the Raspberry Pi. Yes.
that does the recognition, the recognition of the face on the.
Yes.
Yeah.
Yes, it is a very simple for OpenCV. It's a very simple module. So my focus, AI. I want to some students very easy to contact the AI program. So when the students learn Python is so difficult. So maybe teacher he teach them also feel the Python is a little difficult.
It's true.
So my design all the Python, all the AI is modular. Okay. If the teacher want to explore more activity, they can use Python. If we don't, the teacher or the students only use the Lego program can finish. So
With blocky or
yes.
or regular code.
Because the Lego program can show the a block, it can show the Bluetooth and some
Inputs and outputs.
communication
Yeah.
with another EV3. So this is an emulator another EV3 and the communication. If I don't use Python, only use Lego program and finish, they can use
You can communicate.
AI, play AI. Yes.
What age are
So
you?
this is my.
I know, what age?
What age are
Yeah,
your
what
students? What age group are your students that are working on this?
How
What
old
age?
are, how
How
old are
old
the
are they?
students?
Older students.
Yeah. Like
Like
what, what age are they working with that?
higher middle school or high school teacher or
14-year-olds,
14, yes.
14, 15, 14
Yes,
through 18.
14, 15.
Yeah, 15.
Yeah, they,
Some high school like this module. They don't buy the EV3. They only buy the AI upset on set
Module.
A module is
Add-on?
okay. It's very cheap. Only one single board Raspberry Pi.
It's
So this
it's Raspberry
the
Pi.
Raspberry Pi and a camera.
And it comes with, and the camera.
Only Raspberry Pi and a camera.
So they get,
is it a pipe camera?
Yes, high camera, yeah.
Pi camera?
So it is Raspberry Pi and a Pi camera. It's the standard
And SD card.
SD card, right? And they only, some of them only get that. You're saying they like that.
Or they,
He
they
sells
can-
it in a kit.
Oh, that's you stuff.
oh,
You're saying they like that. They don't always buy the EV3, right?
Oh,
No Python running on EV3. The EV3 use original
the block.
Lego
Yeah, the
block
Lego
language
block.
is so simple, so easy to use for the young kids, for the teenager. Yes.
But the old-
in China, a lot of the robotics is taught with the Lego platform. And
Right,
to
right.
the high schoolers and middle schoolers, and so therefore they already have that equipment. So then for them, it's an add-on, yeah.
So you're doing this here in in the States too? Are you here in this?
He's here to share
To
his.
share, okay,
And to potentially expand,
to the US.
yeah. He's trying to
China.
see whether there's a market for
Okay.
his.
I see, too.
This
solution.
this project is AI. I mean AI homework printer or homework printer.
Everybody needs a homework printer.
Yes. So, okay. I only have a one Raspberry Pi. If I can show this, I need maybe 10 minutes.
That's okay.
Oh, can I go next? Oh, who's next? What's next?
Let's see, who is next?
Okay, thank you.
I believe Jim is next. Yeah, Jim, you want to go next and then we come back to him?
Sure, if you want me to go,
I'll modify the.
yeah, mine is, I brought in a box to open primarily here. Now let's switch to, switch my
What this
camera.
environment is great for, the meeting, you gotta go to the meeting, so you gotta get into your software and break out your hardware,
Oh, yeah, I mean, that's,
charge everything.
it's kind of, well, instead of, it's like you either demo something or, box opening is perfectly
Yeah, perfectly doable.
reasonable to do. So this is, so this is the Mark, MARK, Make a Robot
Oh,
Kit.
nice.
And it is also made in China, I believe.
Good acronym.
And so this was a bunch of us in the robot community, either this club or the Homebrew Robotics Club of Northern Cal, noticed this. Someone posted a link to this being sold on Seed Electronics with 3
I know.
and it was only like, it was like under $50, 80% off, and it was normally a few hundred. And so as a roboticist, a lot of us just click buy when that happens.
I know.
Even when it's $200 sometimes, and only $50 off, I would probably.
No brainer.
Yeah, but this thing is, well, let's say here. Yeah, it supposedly has some good features. So automatic driving with signs, image recognition, and obstacle detection. That's some of the things it can do. What's the bottom one? Line following, or they call it visual line following. So it's not the standard line following a lot of us have done was your IR. And this one is visual, so it's camera based. And it looks like it comes with, this is a track, obviously.
That's pretty nice.
Track. This is a track that it comes with. And it comes with these signs as well. This is what I'm interested in. I'm currently taking the self-driving car nano degrees, self-driving car engineer at Udacity, and I'm paying for it, so it's making me go, oh crap, I just paid another monthly fee, and so that kind of makes.
You haven't finished.
Yeah, and it makes, but anyway, these are, this thing obviously has some different, car related
Oh.
signs and then, yeah, your typical image recognition of animals. And this one, that one's a
Oh,
little
no.
bit curious. But, yeah, so, okay, let's open up this maybe I'll just switch to the other camera now. Let's switch to the other camera. Oops, sorry. Logitech. For the top down, this is now the top down look. I don't know why this thing is out of focus, like the bad webcam or something. No. That's better. So here's what it looks like. Now I know Thomas bought this one, and so yeah, here's the board. It's got like they call it the Markduino. So it is it's an Arduino based custom board. So that's a good thing. That's your microcontroller, not and then you got some other parts here. You got a standard ultrasonic distance sensor. This one is the this is an electromagnet. That's probably for, I think it's a solenoid thing that actually moves. And what's this one? This one's line finder. Well, that looks like a standard line finder to me. It's got the infrared sensors there. But yeah, this is the first level. And this one, I forget what this one is. This is part of the structure. This is the main part of the body. And then, yeah, you've got your famous yellow motors, Chinese yellow motors, which are, they're basic, very basic electric motors, but they'll do the job in this case. And then the lower level, we have the chassis, as well with the battery pack. And then, here's the camera. This comes with the camera. And it's a movable camera. It's on at least one axis there. Maybe there's two axes. I think there is. And then here's the wheels. They're about 2-inch. Looks like about 2 inches wheels diameter, not that big. And it takes 6 AA's. And here's the screen. So this is a 2.5-inch LCD screen, and that mates onto that's a lot of hardware there. This is the Maxarduino. Oh, and this might have the AI. There's AI module called the K210. So that's the real thing the real money, the show me the money part of this system is it has an AI module, this silicon here, and the image processing, and that's an ESP32 as well. So I'm offset here to watch. What's that?
We're looking at your watch.
Yeah, that's an ESP, right? Oh, that's the fun of it. Right? So yeah, this has got some good stuff on it. And yeah, the camera plugs in there. So this is like the most expensive part, I think. It's got this AI module. I looked that up briefly, the K210, and it's a dual. It says dual core, 64-bit. It's a RISC architecture, RISC-V, which is not that new, but it's anyway. Yeah, so it's got some hardware in there that can do some. That's much better than your typical Arduino-based robot, and it's equivalent to having something like the a Luxonics Oak AI camera, and that's all built, and a screen, all built in. So, and it's got software and a whole set of lessons. So I'm looking forward to playing around with that. And hopefully whoever else has it, we can communicate more and share as time goes on.
Yeah, Thomas got one. Who else was able to snag one? Ben, did you grab one?
No.
In this group, I don't know. There's a few people definitely around in the other groups.
Yeah.
But yeah, you can still buy it and it may go on sale again. It's a bit too expensive, I think, for most people to just pick up at the full price. But you know, if it does go on sale again, you just keep an eye on C. And yeah, so that's it for me. Thank you.
Thank you, Jim. That was nice. All right, so we're back to Faye.
Yes.
Okay, let's see.
So,
Can you do it with the camera?
oh, okay, thank you.
Do you want me to run the camera, to hold the camera while you put that away, Jim?
Oh, I can put it away later.
Oh, okay.
You don't put it away before I have a chance to look at it.
Yeah,
Oh,
actually.
thank you.
There you go.
So, this project is 3D, sorry, is a AI homework.
So that's
The
that's
Raspberry
your,
Pi, and this is camera. Okay. When the program running, this camera can take a picture to the memory and OCR the picture to the text and to contain the resource and send the resource through the Bluetooth to EV3
Results.
results. Yes, results. And the EV3 receive some data, and they can
print it?
move paper forward, backward. And this is a pen. This is a pen.
Oh,
And write some.
it's a plotter.
So,
Research on this paper.
so it scans and prints.
Yeah.
Yes. Answer on.
OCR as well as printing.
Yes. Yes.
Drawing.
And calculates the answer.
Oh,
I'll show
okay,
you.
so it's a student.
Yeah.
Okay.
It's a cheat
The
for
AI
homework.
program also use Python.
Yeah. And this is all using the EV3, EV3 Lego.
Yes, this is EV3
Yeah.
Lego. All the activity EV3 control. The very hard work is EV3 control this pen to write number.
Yeah, that's-
So you have
Okay.
you have a software that plotting software.
The screen says please put. Sorry. And sensor not work. Sorry.
Yeah, we know about that.
So in order for the student to have the homework answered by the machine, the student must first understand the system and program it. So that is-
Right. If you cheat and do your homework this way, I think you've passed. Yeah, I built a robot to solve my homework. Okay.
So this screen show please put in the paper. When the paper this light sensor, I'm sorry.
Is it loading it?
Yeah.
And the camera focus to the first line. Sorry, I can change. Yes. Oh, I push this EV3 button, and the EV3 send some data to Raspberry Pi. Then Raspberry Pi take picture. Okay. Right. Yes, this is 13 plus 3, 34.
Flash for a moment.
Oh, sorry. Cannot. Sorry. The picture maybe not good as I.
It's the lighting.
Yes. This is a
there it is.
picture.
Maybe
This
there's
is
extra stuff in there.
green picture. Yes. This, and this is black.
I see.
So, okay.
Well, that looks pretty good.
Yeah, just for the demo.
Do you want the big lights on?
Does that help?
Does a
Does
more
the-
light help?
It lost contrast.
It looks good. His picture looked good here, so I don't think that was the problem. So yeah, you don't. Yeah.
So,
Besides, that light is oppressive.
This is a total geek answer to doing the
so
homework.
let me try again. It's not stable.
That should have worked because it looked like a good picture, right?
Wait till you have to do calculus.
Oh gosh. Well, then they're going to be doing control theory and partial derivatives and solving for like an airplane autopilot. This one's interesting too. It's not even through.
Yeah.
Here,
Yeah.
Oh, sorry. Maybe something wrong. Okay.
Do you need more light?
Sorry. Yes. Files.
Oh, it's got an error. 33 plus 34. Oh, 13 plus 34. It got it. It's just got some sort of error, string error, Python string error, or some kind of.
Oh, equal.
Oh, it
What?
didn't.
What?
or did you lose power?
It looked like a
Run out of
Python,
battery.
exception, as we've all gotten in the
Sorry.
past.
It's okay.
Maybe next. Next.
No, that's very
Max,
good.
I can
It
show.
happens. It happens. Don't worry about it.
Yeah.
I could see it said 13 plus 34. It just as a, some error, some condition case that without the equals it didn't recognize.
Then
Anyway, cool.
they can control the model move right and the paper forward, backward, the pen up and down. So write the resource on this page.
Ah,
Okay.
And
This
this
is yesterday I tested the number 2 program, lecture 31.
Oh, I see. We're starting to get it
Yes.
right there. So this
So, yes.
does the student program, or does the student do some work and have to solve the problem?
This is not students do, it's a teacher.
Teacher.
Yes, yes, the teacher John, my team, very good worker, teacher, made this, and the program, I read the Python program and the V3 program. And let me introduce this. This is like a shooting range. That's a shooting range. We can
Targets.
automatically. Recount this, and follow this, and some
Is that,
some little Lego parts to
Oh.
here.
it shoots,
When the motor ran, the trigger can put some Lego
Shoot a Lego.
fly, yes. Okay.
is that a,
I
is that
hope-
like a scaled down version of the Lego, first, what do they call them?
Oh, the FRC competition?
Yeah.
It looks like
Yes.
a scaled down version of the
Maybe.
big robot competition.
Yes,
Lego
maybe. Yes,
Lego
maybe.
First Lego,
First Lego, that's, yeah.
I knew it.
US.
I hope it's very easy to students, to teenager.
yeah.
I don't know about that.
I know that
What, to
Trish-
use it or to actually make it?
yesterday Trish asked me, this is a
College
college
level, yeah,
degree.
I think.
How did you teach the teenager?
Oh, to build it and everything, huh?
Yes, I mean, the focus not let the students clearly understand any line coding, and it's not. I hope they can direct use, like use a sensor, like use a motor. They can happy to play is very.
So it's sort of engagement before the interest kicks in, right? Like you get exposure to the equipment and you see how it's being used, and maybe some of the people who are so engaged might be curious to explore.
They can understand one part of it,
Yeah,
like
one
the,
tiny thing. You
yeah,
know
the
how it is,
motor
like,
or the
Yes,
sensor.
very easy to use.
or follow instructions and then maybe start.
I.
They gotta start somewhere.
Yeah.
Another 4 projects. So this
There's a lot
today
of
I
support.
can prepare, so I don't take 2 years.
Well,
Yeah.
that's
Maybe
okay.
next math.
I'm curious about your RC car modules.
Yeah,
That's
I can
great.
show you more.
Come back.
Yeah,
Uh,
next meeting maybe,
yes.
come back. All right, thank you very much,
Thank you
Ray.
very much.
Thank you.
I am constantly amazed by the things that people can do with Legos. It's very- Truly, truly.
Yeah, that's a great kit.
Yeah,
I had, yeah.
Thank you, Faye.
I like Lego.
Trish, you're up next.
Okay, sadly, I don't have any actual visuals, but except other than my PowerPoint that I've presented. And I'm actually going to talk more than have you read a PowerPoint, but I put this so that I could capture it and remember what I'm trying to say. So, Gofei did his project during the pandemic, 2 years of pandemic, and stuck at home, and that's what he did. And when I was in the pandemic, stuck at home, well, not at home, I actually had the studio I was able to go to. Then I had my own project that I did. So I'm going to share that with you today. And my pandemic projects, I didn't have one, I had a lot. I started a nonprofit, a 501c3, to support grassroots people. I call them makers. You might understand why. And largely, I wanted to have that ability to find funding for my projects. And because it's a 501c3, it reaches out to find and include other makers, because 501c3s don't support just one person. I'm one of the people that it supports. I also started a multinational coalition. What is that, you might ask? I explain that later. I participated in a team for augmented reality. I'm applying for grants that my multinational coalition can support. And I'm focusing in those grants on the local multinational community and the grassroots international multinational community. Say that 10 times fast. And so what does that all mean? Okay, starting with the nonprofit. this is the website for the nonprofit. There's a board. We started this program called Sidewalk Spaces, where we go to people where they live and work and go to school and play. And there's a community at 3rd and Elm that we're developing. We basically literally do activities on the sidewalk. We put a table outside a business and we do activities. And I got a couple of little tiny grants, $1,000 grants, a couple thousand here, and it worked. We had a symposium. We did an event over at Long Beach City College, and that was in April, and that worked out pretty good. And then we're possibly considering getting a booth at the Comic-Con. I mean, I had that as the goal, but I first have to write this comic book so I can take it to the Comic-Con. I actually have some ideas that'll get me there, and that's in September, and the 3rd and 4th of September. So it's a possibility. If I do get the booth, I will, of course, let you know, so that if you're interested in participating, then you can. The multinational coalition is kind of the big accomplishment or pre-accomplishment. And I gathered people who have been kind of observing the way I work and what I do. And I got a letter of interest signed by the CSULB Institute for Innovation and Entrepreneurship. Some of you may know about it, but they serve entrepreneurs and help them gather ideas, you know, come up with business plans and things like that, and help them move ahead. And there are a lot of little moving parts that are part of that. The City of Long Beach's Department for Technology and Innovation has also signed the letter of intent. And that group is responsible for bringing technology, more technology to Long Beach, however that might look. And this last year, it was the augmented reality competition, which is how come I came to know some of those people. And this year they're working on education and maybe some computer-based stuff. The Long Beach Qingdao Sister City Association, which is a sister city group, you know, you may know Sister Cities, created by President Eisenhower for people-to-people interaction. So in this case, here you have one person, Gopay, and you have me, Trish, different countries coming together to figure out, you know, interactions. I have a company called Edis Inc., tiny, and but it's been around since 2013. And then there's Makersville Services, which is a new 501c3. And so this multinational coalition serves serves the community. We have the government, which is City of Long Beach, educational institution, which is Cal State Long Beach, could also be Long Beach City College, which we hope to add next year. Nonprofits and for-profits, which is like, you know, these youth serving organizations. Maybe it's the Convention and Visitors Bureau. Maybe it's a local business like the businesses on whose sidewalk we work. And then here is the new for-profit that I'm visualizing could happen, because we need an entity to support the for-profit action, because it is entrepreneurship. You have to have a for-profit organization and the nonprofit there. Hard to understand if you're just hearing it in 5 seconds or 5 minutes like this, but basically the yellow is a gap that's missing. And if you have ever had a project and not had a for-profit to umbrella it, you will know what I mean, right? If you have a for-profit, you can go find funds, you can find grants, you can gather funds, you can ask the people you want. And in our country, there is a huge bias for nonprofits, right? So, but lately there's more of what you call CDOs, community-based organizations, and those organizations may be either, right? So these are the augmented reality projects that a couple of really good ones that I liked, and then the one that I created is at the bottom. So you can take a look at it if you like. I'm just gonna go forward. So I'm currently applying for grants that the coalition can support. And But what I'm writing right now is 3 major grants. This is going to be submitted in another day or two. The deadline is on Monday. But I shaped the grant to be makers in the community, makers in schools, and economic inclusion for makers, so that people can find a way for their things to be supported, for their projects to be supported. And if you're familiar with the maker movement, anybody can be a maker, because anybody can make something, whether it's a hard-boiled egg, a cake, a robot, right? Everybody, we're all makers. That's the philosophy. It's an inclusive thing. So I'm starting with the city grants, Long Beach City grants for economic inclusion. And those are currently focused on businesses, inclusion of businesses. They focus on certain ethnic and racial demographics, benefit to, and certain areas of Long Beach that were heavily hit by COVID. And my goal, now this is outside of the multinational coalition, I'm personally interested in finding ways to extend to other cities in California, so that I'm not only dependent on these grants, but I'm also going to be looking at bigger grants that I can get. Because now we have some argument, right? We have a package of substance that we're creating, and people who are supporting, things like that. So when we talk about the international, multinational community, I have one student in Norwich, England, that I'm connecting with every week. Her dad is a computer science teacher in high school, and somehow we reconnected. I'm not exactly sure how. I think I asked you to join the LBQA, and he joined, and then he said, hey, I was coming to check this, to show you this stuff, and I want to come check it out. So I'm like, okay. And then we remembered that the meeting was today, so I said, okay. So I personally, and this is outside of the multinational coalition, I'm interested in finding ways to reach other countries and to work with students from other countries, because multinational is multinational in Long Beach and multinational outside Long Beach. And then this is sort of like a goal to bring people together in 2023, perhaps. Teams working together to solve problems, create products and curriculum, including kids. Key point is multinational teams and problems are not defined before the games begin. Because if problems are defined before the games begin, people will work on the answers, and that's not the point. The actual thing is to have the team work on the answer together. And then there's an annual regroup that I plan, which, you know, I'm trying to transition this giant idea to the team of multinational entities and have them find people who will help to support all of this infrastructure I want to create. But first, funding must happen. This is a completely separate thing, but this is how I see some of this working. I got a grant from Vaccinate All 58. I told a bunch of people, we have $400 in royalty fees if you want to help me create a DIY video for the Makersville YouTube channel. And the goal is, so here, because I'm asking this group, it would be nice to have a robot in it. It could be as simple as the robot saying the words relative to the grant, but I had an idea this morning for a funny robot skit. They're trying to get people vaccinated. And so in this case, the robot says, I'm here for my vaccination. I don't want to get a virus. And the human at the clinic says, I'm sorry, COVID-19 vaccines aren't for humans. And then the narrator says, are you human? Visit myturn.ca.gov to find your closest vaccination site. And then I have a trailer I will put up. So if anyone wants to help me with this, I would be happy to do this with you. And then it's a $400 royalty because the grant was paid for. Anyway, so that's it. That's all I have.
Thank you, Trish. Very informative. Thomas, you're up next.
Yeah, I only have a really brief thing. It's not a robot or anything. It's tangentially related to everything going on here. First thing I wanted to show you was 3D printers. How many here have a resin 3D printer? Put your hands up or say me or something like that. Anybody have resin printers? Not a one. Well, the price has come down considerably from what it was, which was thousands of dollars. And now I'm seeing them for hundreds of dollars. Let me show you right now. I'm going to share my screen here as soon as I hit the right buttons. Can you see it?
Oh, yeah, those been pretty cheap for years.
Yeah,
The only-
it is. Well, it's new to me.
Oh, yeah, they've always been like maybe 300, less than 600, definitely.
Well, now it's
Uh,
200 or.
I see one for $100, $100.
Well, look at the top row there, 99, 99, 99, 99.
Yeah, they're cheaper, but
I thought they were
weren't that.
500.
Yeah, they weren't that expensive, but yeah, these are definitely a lot cheaper.
They're messy though. That whole
Yeah,
process is
the only
messy,
reason-
chemicals.
Exactly. The only reason I've never gotten one is because you have to have the alcohol solvent and all that stuff in hand, and I don't want to have that kind of stuff in my house.
It's
Smell
kind
it.
of toxic, right?
Yeah.
Well, even in the garage might be okay, but it's messy.
It is messy, and the chemicals that you need to have on hand, and I don't want them.
And you have to clean it, like clean it afterwards, right?
But they are nice.
And
Yeah,
you,
the prints are nice.
the prints are,
Yeah.
Very
they're
cool.
Clean.
you can, yeah. Oh,
My point was they're going for 99 bucks. I went to their Crealities or website themselves, and they didn't show those cheaper ones, but they showed this one, which was $200. I'm guessing that these are out of. I'm
No,
guessing that
that's
these.
for
But they do have a small
print volume.
print volume.
Yeah, you probably want to use it on things that you needed that ultra crisp, high resolution. I don't know what the numbers are between this and a standard 3D printer, but I do know it's a lot finer, but I don't know by how much. No, that's
Yeah,
all.
they can
What's
be
that?
useful for certain applications.
Jim said that they could be useful for certain applications.
Better.
They are.
Better than fused filament, but.
Oh, yeah. I
But
mean,
yeah.
there's no question that they do have like some really high resolutions. Prints come out beautiful. But I mean, if you have the facilities or to, super ventilate your area and somewhere to like, contain the chemicals, I wouldn't have that in my garage. I don't trust myself with that kind of chemicals.
Yeah, Alan has a laser printer, a laser etcher in his garage without a human, professional.
Oh, no,
user.
I've been to the outside when I use it.
But it was a homemade thing, not a.
Yeah, it was heavily modified from.
Without like a, yeah.
Aside from how messy they are to work with, the chemical resins that you use are toxic, and they're the kind of toxic where the first time they touch your skin, you'll get a little bit of rash. The second time, you'll get a larger rash, and then the third time you can go into anaphylactic shock.
Really?
Depending on it, yeah.
You mean it gets worse?
Yeah, so you always wear gloves, you never contact it. Drying them is a pain, and I don't know about you, but I'm not comfortable keeping a gallon of 90% distilled alcohol in my garage.
That's what I'm saying. For flammability.
Seems rather flammable, yeah. So it's the right tool for the job. You have some beautiful prints. They're not as robust as 3D printing. So for my stuff, but I keep looking for an excuse. I keep looking for, now I have to get one because the prints are so nice looking.
Yeah, they are.
It depends on what you're doing. Like for robot parts, like, the things I just showed you, there's like, it doesn't matter if it looks that nice. But if you like little figurines, and I've printed my, share on the regular Philip fused filament printer, then you can really make beautiful one. If you're an artist and a sculptor, that's the way to go, but
But
I'm not
you still need to have like the right facilities to contain all the chemicals, but, because if you're just gonna have, you know, everything on the shelf in your garage, no.
oh, you're saying even a garage, yeah, even a garage is a dubious place to have.
Yeah,
Well, if you have one of these fully enclosed, but then it's,
no,
the-
it's even, I mean, you gotta have the
It's the
chemicals
chemicals.
somewhere.
well, obviously they're selling them, so some people are doing this.
A lot of
And it's,
people are-
they have to meet certain federal requirements for safety, I assume. No?
But speaking about the resolution, when you're printing on a typical plastic printer, I'm running my robot parts with a 250 micron layer height, so that's 4 layers per millimeter.
Yeah,
Your
yeah.
absolute best, layer height for that type of a printer is usually 100 microns, 1/10 of a millimeter. I've toyed around with 50 microns, but there's no point and it just doesn't really work.
Hmm.
The layer height in these types of printers start out at 10 microns. And I think their coarse mode is 15 microns. So
Wow.
super fine,
Hmm.
smooth detail. Oh, so nice.
Yeah. Although you can, I mean, you could, if you want to go the toxic route with a fused filament printer, you can do ABS and then dissolve it, and then you can bathe the ABS finished print in a bath of what is it?
Acetone.
Acetone,
I've done
and it
that.
comes
Yeah,
out beautiful.
I've done that.
I've done that.
Oh, you've done it?
Deposition, yeah,
Yes.
for
And what
parts.
position?
Um,
Oh.
Yeah, so again, you've got a cloud of potentially
It's
flammable.
messy.
Yes,
So there's.
So you guys
visibility
did
and
that?
safety. Oh, yeah.
I created my own little vapor chamber in the backyard where I was vaporizing acetone and putting the parts in there. They come out beautiful, but.
Oh, you have to vaporize it. huh?
Wow.
Yeah.
Yeah, there's a technique where you take a bin and then you dip a couple of paper towels in to get them wet, and then you drip them over the side, and you put the part in, and then you close it, and then you put an incandescent lamp off to the
Oh.
side, but outside to warm it up to about 100 to 110 degrees. And it does get them smooth, but you also lose detail. So it's the
Yeah.
fine detail that
It's a
that sets
careful,
the resin printers apart. Yeah.
But
oh,
the-
right.
yeah,
So-
they
so
do
yeah,
come
yes.
out super smooth, shiny, like something you bought off the shelf, but it's still, it's a process.
Yeah, it's just like, it's a very chemically intensive and industrial process.
I even tried the same kind of technique with PLA with this even worse chemical.
Oh, really?
Yeah. It is. So I actually have some of that liquid. It's a bad. No, it's not something you want to have lots of it in hand. It's
You don't store it on low shelves with
No.
small children
No,
and
no.
animals.
it doesn't work as good as acetone and ABS, but it does smooth out PLA.
Oh,
But it's not.
but so if you've already done that and you think these printers are dangerous, then I'm not touching them.
I think they're more for, like shops where that fine detail is critical, right? Yeah, like maybe,
Yeah,
fulfillment shops,
you could also
pawn
join,
shops.
you can go to your local, you can try it out at a local makerspace if you have a membership, or I don't know, get a trial membership or take a, or, do some kind of, or ask for a demo or something, because that they will have them in under safe conditions, right? A makerspace.
Maybe.
They have
I mean, they
If it's a
they
good-
have the ventilation systems and all that stuff.
Well, they have to, because it's,
That's right, because if
the
they're,
places are inspected.
are you talking about like,
Well, There's one in, right here in
Irvine.
Costa Mesa. I forget the name of it right now. But it's really, it's a big building with lots of equipment and,
oh, yeah. they-
everything
they
from
do
electronics,
cars.
machine milling, wood, everything. And they have 3D printers too. I don't know, yeah, and resin.
They seem to be doing okay.
Okay, I think so. That, after COVID,
On such a big space, it's hard to manage that.
But they're expensive, those things, those maker spaces, for customers, monthly fees in the hundreds, and it's, or at least, yeah, but they have free courses to teach you how to use all the equipment. I've been tempted to do it, at least, for a limited time. People open their businesses and like work out of that. They have like a whole area that with their monthly fee, they get storage and everything, but anyway. They give free tours. Yeah, I recommend.
Yeah, so,
Urban Workshop is the one I'm
Yeah.
talking about. You familiar with that?
but yeah, I mean, resin printers, beautiful prints. When I saw them years back, they were like, 600,
Yeah, that's
400, 300. I looked into it. They look beautiful. It was really tempting, but no.
All
yeah,
right,
not for
moving on.
Sorry.
No, that's fine. Yeah, they're toxic, they're dangerous, but oh man, the prints you can get out of them, they can be really beautiful.
Yeah.
Yeah, I can understand you might be interested because your robot's a humanoid and you want something to if it's a humanoid robot. Although most of the things you get, you have to buy from from professional kind of organizations that make latex molds and all that. Or
But you could, with a little elbow grease, you can do a PLA print, sand it like Helen did with the InMove.
Yeah,
And end up
Oh,
with
yeah.
a beautiful.
and what Walter does all the time.
Yeah.
Walter's
Those are other dangerous chemicals when you're sanding and filling.
Yeah, that's true. That's true.
Oh, yeah.
All right, the other thing I came across was I wanted a terabyte drive, a flash drive with a terabyte. And I did a little search on Amazon and some are coming up at $149. Can you see that?
Yeah, no, that's not, I don't know, maybe it has like some other security stuff in it that.
Some are coming up at $149 and some were coming up $22, $25. And I said, well, these are getting a lot of good reviews. And then I rolled over and said, oh, okay, 3/4 of them liked it a lot. And then I took a deeper dive. Here's the 149, and it had really good reviews, and that's fine. And I went to the cheapies and read some of these reviews. Very unique and stylish. We're talking about a USB drive, okay? Game changer in the kitchen. Kitchen tool. I'm getting several for the ladies in my life. Okay.
Those are like stacked. Those are like farmed. We call it click farmed in.
I don't know how they're doing it, but they have all the 99% of the 5 stars say are not for that product. Great on side of sink where dishes dry. Boy, that's where I got to keep my thumb dry by the dishes. We are the Jedi.
That looks like just a mistake. Even
But look at the
that doesn't even look like it.
Patch looks amazing. Look at that patch.
Yeah, I saw an article. It's a bit of a scam where they get a product that's really successful and then they just change the product out to keep the reviews around. So yeah, there's reviews are for a previous product that had that same product ID, and then they just change everything.
Oh, you're kidding.
How can they do? They can keep the product ID and just change the content.
And this has been several different products. Look, very cute pin. So it's been something by the sink, some pins, some patches. Looks great, and you get 5. Oh, now I know I get 5 of them. Using it in our motorhome. Well, because it's you need one if you pack it in your motorhome.
Well, that's true.
On and on.
Yeah, I mean, depending upon how fancy a motorhome you have.
So what's the bottom line? What's the bottom line on whether those sticks are any good? I would go with the more expensive one.
I don't know, I mean, those cheap ones are cheap enough that, you know.
They might either perform very slow or
Yeah.
some.
They're not 1 terabyte drives.
With some of them,
All
A lot
right,
of
we
them
need
are
to
not-
get into it too.
a lot of them are not USB 3 drives, they're USB 2. And if you
Yeah.
get all the fake reviews, you probably have 90% of them in the 1-star rating.
Yeah, I'll be on the lookout that for in other Amazon shopping.
So thanks for the lookup, Thomas.
Yeah, this flash drive died after the first attempt. This is not a USB 3 drive. This flash drive does not function well at all. My files got corrupted. Data corruption, transfer is slow, didn't work, doesn't work, worthless, do not buy it, a poor choice.
Well, but even Facebook has spending, it has security and a whole division to handle bad posts and toxic language. Why couldn't Amazon have a division to handle fraud? They have to have some fraud handling. I don't know.
Yeah, that whole reuse the product ID shouldn't be allowed.
Maybe that, yeah,
At minimum, right?
I haven't seen this level of
Wow,
poorness.
look at that metal one, $18.
What's funny is that's a real, it's a Samsung, I think, but that's not gonna be the device yet.
Oh, you mean the picture?
Yeah, I think I purchased one of those at one point.
I have one here, kind of like it. This guy.
Yeah, that's it.
Oh, it's a little small one.
Yeah.
They were perfect for her to throw in her bag and draw any time. My daughter loved them. Nice little notebook. It was a notebook.
All right, you made your point.
Okay.
We're digressing.
I think we've seen enough, Thomas.
We're digressing,
All right.
but we're
All right, then, guys. That's all I had.
All right, I'll take a few minutes afterwards.
Okay.
dutifully warned.
So we have one last show after Thomas.
That's it.
All
All
right,
right, thanks, Thomas.
Sure.
Alan.
All right, I'm gonna take it upon myself to give you an update on the state of graphics cards in gaming. Not necessarily for gaming, but for the deep learning aspect. Big Nvidia fan, not gonna hide that. So a lot's happened over the past month. Let me go ahead and share my screen just for a quick second. Go ahead and so the price of graphics cards in the new and the used market is continuing into a free fall. I don't know that we're at the bottom yet. The market's getting flooded with people who are getting out of mining and dumping their cards in on eBay, Orange County Craigslist. So they could represent a much better value than 3 or 4 months ago if you're looking to upgrade. Also, the retail channels have stocked up on the probably the last production run of the RTX 3000 cards. And those prices are finally dropping down to the advertised MSRP from a few years ago. So the 3080s in this example, I'm just pulling up Newegg and doing a search for RTX cards.
3090s.
It's within $100 or so of what its original retail was. The 3090s are dropping towards what their original MSRP is.
1600.
Which is great. I purchased my 3090s at around 2,000 a piece.
Oh.
And at their peak, they were being sold for $4,000. Now they're back down to a reasonable price, which is great. So if you're hankering for an upgrade now, it's not a bad time. I don't know how much better the prices are going to get.
This is good.
But here's my prediction. I'm not going to bet you lunch on it. Just looking at the market. Anyway, as we get closer to that next Ethereum, the merge, which is currently slated for August now, it keeps slipping, but it is going to happen. There's going to be a mass exodus from that market, and the market's going to be flooded. Do you think I'm talking about it being flooded now? It's going to be super flooded as everyone has made all their money back. They've, at a profit, they're dumping the cards, which will drop the resale used market even lower than it is now, perhaps as much as by 50% over what the used market is right now. This in turn is going to have an effect on the retail channel for new cards. I strongly believe that the retail cost of cards is going to go down in an attempt to make them more palatable than the used market. How much? I don't know, 10%, 15, 20%. So I'm predicting the price will down at least a little bit. And because I'm hearing that the retail channel is completely restocked with this generation cards, I think this is going to delay the introduction of the 4000 series that I was talking about last month. The ones that are twice the power, but twice the performance. I don't think they're going to introduce those until they're able to deplete what is now new stock for the current generation. It just wouldn't be smart to. So if we're lucky, we'll see the introduction of the 4090 towards the end of the year, or they very well could delay it until 2023 to give the retail channels a chance to get rid of their existing stock, which they are going to have a hard time doing when you can buy a gently used card on the used market for half the price.
Okay, so a question. All these cards that people are gonna be dumping that they were using for mining, would you recommend if I were to grab one of those at a huge discount and use it on my PC just for gaming?
Yeah, it all depends on how they're used. So in my understanding about it is that when you're looking at the hardware and it's being run 24/7 and elevated temperatures, I think that there's more damage to the board from playing a game for a couple of hours and letting it cool down. That expansion, contraction, it's designed for it, but that's a mechanical stress. If you're running it 24/7 with an allowable temperatures and an open frame mining rig, that's like nirvana for a graphics card. Okay, so they're operating at 60, 80 Celsius, but they're designed for 120. And there's no expansion contraction, it's just being used. The fans are constantly being used over time, so that is something that could wear down. So when I buy a used card, I always make sure that it works first. So, if it's Orange County Craigslist, I know it may seem risky, and I actually haven't, my new cards have all been in box. You want to make sure that it works first. So however you can do that. And just, if there's, just find out a little bit about the situation it was used in. If they're being all cagey and, okay, we'll move on to someone else. There's going to be thousands of cards available. But if it was open air, there's really not a whole lot they could do to abuse it. Now, if they were mining on the parents' PC and an enclosed, they stuffed a big card into a little case and it was overheating this whole time, that one's not going to fare very well. But yeah, I wouldn't have a problem. Buying a mining card is like buying a gaming card. It's like there's so many unknowns, but I wouldn't not buy one just because I knew it was mining. I'd want to find out more about the situation it's being used in.
Why are people getting rid of mining?
Yeah, what's the
So towards the end of this year, the largest cryptocurrency network, second largest, Bitcoin is the one that started it all, and this slightly smaller one, Ethereum, they're switching from a way how they verify transactions. Right now, they get graphics cards to crunch numbers as part of a process to verify transactions. It's a huge carbon footprint. You jump in, you use your card for mining, you get a little bit of a reward. They're switching from that model, which is called proof of work for the work that your card does, to a new model called proof of stake, where you basically stake 32 Ethereum, and then you put your reputation on the line when you verify a transaction. It's a lot lower carbon footprint, like 99% less. But as soon as they move over to that, there's no need for miners. And these miners are kind of stuck because you can't move to another coin. There's no value in it. Anyone who tells you they can move to another altcoin is deluding themselves. So all of your gamers that are part-time miners are going to go back to gaming. Everyone who bought cards just for mining are like, well, what do I have this card for?
I mean, they can't start working on a different coin.
No, they absolutely can, and some of them will. But if you have 1 million people mining for one coin,
And the reward is divvied up among
Oh, I
a million
see.
miners, and there's enough of a reward for them to show a profit. If there's a much smaller coin with a much smaller slice of the pie, and all of a sudden you dilute them by 1,000,000 times, there's no
I
no
see. It's
profit
like,
there.
why am I doing this
Yeah,
anymore?
yeah. Yeah, so I'll take it upon myself to keep everyone updated as this story progresses. Now's not a bad time to jump in, but if you're looking for a super great deal, hang tight a couple of months. So if you don't notice through other means, I'll let you know when the floodgates open.
All right, we got
Yeah,
that on the
please.
record, right? So
Please
now we'll
vote.
see in a couple of months, we'll come back to
Uh-huh.
this and say like, oh, is it about $400 now?
Yeah.
It was at 5.
Thank you, Alan.
Yeah,
Yes,
yeah,
thank
post any info on the website
Oh, yeah.
or just email a couple of us.
I just, for the record, have to say
Oh,
that
look at
Bitcoin still
Thomas
confuses me.
has a afro.
Oh, blockchain.
Blockchain
You should,
confuses
you
me.
should read it, just Google blockchain basics and read the one or 2 pages.
I don't know, you know,
Because
I,
you don't need to know. Well, I would ask,
I should.
if you know, Alan, how, isn't it gonna still take a considerable compute power to do the verification? And how does that, or is it just less now? 'Cause
Yeah, it's several orders of magnitude less.
I
It no longer requires all these computers to do the heavy lifting and the crunching of the calculations. It's now a fewer number of computers that are now sticking the reputation on the results instead of consensus. Well, it is consensus.
There's a lot of duplicated work is being reduced. That's because the system, the blockchain system before was a lot of duplicate.
Hugely energy inefficient, yeah.
Oh, I
Not
didn't
great.
realize that, yeah.
I always think of blockchain, it's the least efficient database system you could ever come up with. And the single feature that it has is that, that provability that, you don't have to trust anyone. It's all about trust, but otherwise it's the worst possible database you can imagine.
But it's a great direction for humans to go in. We don't trust anybody ever.
Right. I think there's room for like a consortium of database companies to just do something that's very similar, but at a lower cost, so. All about trust, so.
It's about trust. It's fundamental part of human civilization and business and commerce.
Right.
Anyway. Good talk.
All right. Anybody else have any other show and tells or anything? If not, we can wrap it up.
I would like to thank Ron for bringing these lovely avocados for those of
thank
us
you.
who attended in person.
Thank you, Ronnie.
You have a tree.
Yes. Love
Haas, they're Haas.
Oh, great tree.
And for the record, I have a tree too, but the squirrels are eating all my avos.
Oh, no.
Oh,
I know.
I hate to see
Yes,
squirrels
we are.
eat a lot of everything.
They're getting them before they get into any size at all. They're like still, we have 2 left.
I'll be happy to have squirrels. I have a possum.
Oh.
In my backyard.
Oh,
I like-
possums are so
I like
cute,
possums.
though.
You wanna come get it?
They're so lovable.
You wanna come get it?
They're just a little hissy.
You wanna come get it?
They have a face only a mother could love. Or I guess in this case, a father.
Oh, they're beneficial though.
I
They
thought
are,
I had
they-
killed one once.
No.
Are you-
It was playing dead.
It really was?
Yeah. I came out the next day and I'm like, where is it? Tried calling the animal control.
I'll be happy.
Yeah,
to
I've
have a
had my.
squirrel.
Oh, really? Yeah.
I'll be happy to
I
have a
think
squirrel.
possums are kind of cool. They're